Good afternoon, everyone. Thank you for joining our session today. We are back with our second session for this week. As we went yesterday and we learned about AWS DevOps services, which was hosted by Ishan Saha. Today, we are back with another service, another session, which will be talking about AWS networking and different content delivery services on AWS, which will be hosted by Faisal. Before I hand over to Faisal, let me quickly raise out a couple of points. Please, we are almost on the verge of completing more than 60% of our entire bootcamp. Still, if you haven't registered with us, please do so today itself. The link is given in the description of the video. And for the folks who have registered this week, we will be releasing the link for the Discord channel in a form of an email by end of today. So please, just in case if you don't receive the email by end of today, do reach out to me or any of the organizers or organizer on the LinkedIn or any other forum. We'll be happy to help you out. Along with that, let me give you a quick introduction about Faisal. So Faisal represents the AWS user group Hyderabad lead, and he is actively contributing across the community, and he's a very renowned across different communities. So let me bring Faisal to the stage. Hey Faisal, welcome to today's session.
Hey Sanchit, thank you. Let me just quickly bring up my screen, 1 second.
Sure. Yeah, the screen is visible.
All right, Sanchit, thank you.
Thank you.
Good afternoon, everyone. And thank you once again, Sanchit, for that introduction. And I hope all of you have been joining in to all of our sessions and enjoying the sessions so far. I'm happy to see you all here today. And we have quite a session lined up for you today. First of all, I think this is actually session 9, not session 8, so apologies for that. We have quite a lot to cover today around networking and content delivery. This is normally going to take me about 6 to 7 hours to complete, but we're going to try the impossible today, which is trying to do it within about 2 hours, all right? So I hope every one of you are going to have full concentration on this so that we can get started with this. So let me... Okay, so let's get started off with giving a quick introduction about myself. So who is this handsome chap that you see on the screen? This is Faisal Khan, which is myself. So what do I do for a living? First of all, I am currently founder and CEO of 2 organizations. One is Ecom India Cloud IT, which is an India-based company, which is actually an AWS partner. So we do a lot of cloud migrations and basically digital transformation. Then another company called Excite Logic, which is based out of US. We're kind of in a stealth mode startup right now. We're building out a SaaS product for the entire globe. So hopefully you'll see the products coming out soon. On the AWS side of things, what I do is I am currently the AWS user group lead for the Hyderabad user group. So again, I'm really glad to see all of you joining into these sessions. I'm also an AWS community builder. We actually kind of help push all of the new AWS services into the community, talk about it, and also, as part of being a community builder, doing these sessions are also kind of part of that. I'm also an AWS certified solutions architect. And there are other things also that I do. What do I do other than this? Well, I have a YouTube channel, which is under EICIT Learning, which is kind of related to Ecom India, but it's more or less about AWS training. So do have a look at it when you find the time. Also, I recently started out with my own brand of merchandise called Racer Parrot. So what this is basically if you're into Formula 1 and if you're into racing, you can go to racerparrot.com and you can actually have buy some merchandise that's kind of around the theme of Formula 1. So do have a look at it. It's also there on Amazon if you want to go buy some t-shirts. Okay, with that out of the way, let's look at what we're going to cover today. So we have a lot to cover, which is VPC in major. There are a lot of things within VPC that we'll touch on in terms of IP addressing, in terms of VPNs, DirectConnect, all of that. And then we'll look at Route 53, which is basically to do with the domain names and all of that. And hopefully, if time permits, we'll also look at the content delivery services, which is Cloudfront and Global Accelerator. So we'll start off with VPC, which is virtual private cloud, and let's see what we're going to cover today within VPC. Within VPC, we're going to look at how things were before how things were before VPC came around, because VPC did actually come after AWS started, quite a few years later. Then we look at all of the different concepts and architectures of VPC. We'll have some basic background around networking, which is we'll look at how IP addresses are handled within AWS VPC. We'll look at how the routing takes place within VPC. We'll look at things like endpoints and gateways for VPC. Then post that, we will talk about a little bit about VPN connectivity and how you can get connected with your VPC from your on-prem. We'll talk about some security services, things like your NACLs and your security groups, and also logging for your VPC. And all of this, we'll be doing some labs. So this is just the VPC part. So let's get started off with that. Let's talk about how things were before VPC, right? So you had a bunch of users that were trying to connect into AWS. So this is your AWS cloud. And then, you had your EC2s within the AWS cloud that you used to have. The thing was that this AWS cloud used to be a flat network. Like there was no separation of network within the AWS cloud at that time before VPC. So essentially what happened was if anybody else started their EC2s, they were also kind of on the same network, right? So the only way you could actually protect your individual instances was by making use of something like security groups, etc., right? So there was no separation as such. So anybody else who launched an EC2 was kind of within your same network as well. And it was like a flat network. Of course, there was virtualized separation, but that was not really on a network layer. So what VPC did essentially was VPC brought in the concept of network separation on a virtual level. So think of it like this. If this was all of your EC2s, you can basically kind of draw your own boundary for your network, and this essentially becomes your VPC, right? So you're just kind of assigning yourself a part of the AWS cloud, which you then control. Because once you kind of make this kind of make this border within your within the AWS cloud, this complete set is managed by you, right? So only you can launch your EC2s into this. Only you can manage who is able to access inside this network, who's able to take traffic out of this network. It's kind of completely managed by you. So essentially what VPC was, it's basically a separation of network. And also before VPC came around, if you had to kind of like there was no connecting to network as such. So you were basically connecting to each individual EC2 instance per se, right? So there was no concept of you connecting into a network and then connecting to your instances. But now that you have the VPC, so think of it like this. Now that you have the VPC, essentially you can kind of have things like the VPN gateways where you're connecting to the VPN, and then from there you're basically inside the network, so you can basically connect to any instance if you wish to. So there are some advantages of obviously having your own network, because it's virtually separated. You get to control your own access patterns. You can actually get your on-prem to connect in to the AWS cloud now that you have your own network. So let's look. Okay, so VPC is essentially a virtual network that you are defining. So you can kind of define how large your network is, right? It allows you to completely control your networking environment. You can then, now that you have a network inside AWS, you can actually connect VPN, or you can connect your on-prem into AWS, because now you have a point of connectivity because you're connecting into another network, right? And of course, if you have multiple VPCs, you can kind of always connect them together as well. Guys, just excuse me for one quick second, please. Thank you. Apologies for that interruption. So essentially, we're talking about what a VPC is, right? So let's look at how do you visualize a VPC, or how does it look? How do you put it in your memory? So think of it like this. Think that this is the AWS cloud, right? Let's just virtually assume that this is the AWS cloud. So what you're doing is you're creating your own network inside the AWS cloud, right? So think of it like this: that this is your VPC, right? Now, when you create your VPC, you're essentially creating a large network, right? So you kind of need to control it in a better fashion, because controlling a large network can be a little bit difficult. So you kind of break the network into smaller chunks known as sub networks, which is basically subnets, right? So you will create smaller networks within your VPC, and these are basically called your subnets, right? And the reason you're doing this could be many. Of course, you get better control of your network, because now what you can do is you can have different access patterns for one of this subnet. You can have a different access mechanism for one of this subnet. You can have a different access pattern for this, right? So you can kind of have different controls set up within the same network. And of course, once you have this, you can kind of put your web servers in one subnet. You can put your databases in another subnet, put your application servers in another subnet, because as an example, your databases are not public, right? So you have to kind of keep it private. So the subnet that you create here will essentially be a private subnet, right? Which only systems within the VPC will have access, or you'll kind of define who has access to this subnet, right? But maybe your web servers or your application servers, they might actually need public access, right? So you will have different access pattern for this particular subnet that you create. This is kind of the reason why you're kind of breaking up it into different subnets. Now, apart from this, you obviously have a router within your VPC, which is going to basically route the traffic between all of these subnets and also outside the VPC. Then you have gateways that are part of your VPC. This one being your internet gateway, and this one being like your VPN gateway, right? So we will talk about these gateways separately. Now, obviously, you will have connectivity between these subnets and these gateways, and think of these connectivities as routes. So you're basically creating routes where the traffic can flow through. So routes, router, gateways, VPC, and subnets, right? So you have your subnets, you have your routes, you have your router, you have your gateways, and yeah, of course, you have your VPC as well, right? Now, obviously, there are many other components that are involved in the VPC, and we'll have a look at what those are. But apart from your VPC, let's talk about your on-prem. So let's assume that you also have an office outside of AWS, which also has its own network and it has its own subnet. And you will obviously have your own router, you will have your own application servers or internal servers, whatever you would like to call them. Now, remember, I told you, now that you have a VPC within AWS, you can actually establish a connectivity between your on-prem and the VPC. So you actually make that happen through a gateway, right? So you get your router to connect through a particular gateway into the VPC. Now, essentially what you're doing here is you're creating a VPN connection, right? What you're doing here essentially is you're just creating a VPN connection. And this VPN connection happens between the customer router, all right, and the AWS gateway, right? And we'll look at how this functions in a second. But essentially, once you establish this connection, what's going to happen is this entire network is going to become private for each other. What that means is anybody who's within this network, right? So anybody who's within the Office network can now access the AWS network privately, right? Because now you have basically a VPN connection that's active between those networks. But anybody trying from outside might not necessarily have that privilege. So anybody coming from outside, you're not necessarily going to put them through the VPN gateway. Instead, you would actually let them enter through the internet gateway, because that's the access for your VPC to the outside world. So you have a private side for your VPC, and you also have a public side for your VPC. Anything that is going out outside of the network, which is basically leaving your VPC and going to the outside world, all the traffic will almost always go through your internet gateway, right? You can call this IGW. So anybody trying to access your network will basically be using the IGW, which includes trying to access your websites that are there on your web server, right? But within your office, I mean, of course, you can actually choose to go out to the internet and then come in through the internet gateway. You can do that from the public side. But when you already have a VPN connection established, you wouldn't want to do that because you already have a private connectivity. So you can just connect through the private network itself. Now, I'd like to make this session as interactive as possible. So if you do have any questions that come up, please post it as immediately as possible because there is a 30-second delay. So if you do have any questions, post it as soon as you can so that I can see it and I can answer it. Any questions so far, guys? All right. Don't think there's any yet. Okay, so let's move forward. So this is an image that I want you to burn into your memory because anytime you deal with any architecture within AWS, these are kind of going to be your building blocks of any design or any architecture that you're doing. All right. So you will always have these base components that you're going to design when you start drawing an architecture for AWS. Now we look at what these components are individually. But essentially, you have within the AWS, you have something called a region, you have availability zones, you have your VPC, and then you have your subnets that are part of your VPC, right? So we'll see how this works. So within AWS, of course, you have your VPC. Your VPC is actually stretching across a particular region. What I mean by this is your VPC is always within a particular region, right? So it doesn't stretch across multiple regions. However, your VPC does stretch across multiple availability zones, right? So remember, a region does have multiple availability zones. We kind of discussed this in our very initial intro session. But your VPC is always limited to a region. Of course, you can have multiple VPCs in the same region, or you can have VPCs across different regions, and you can always get those VPCs interconnected. But a VPC is always within a region, but it stretches across multiple availability zones. Now, when I say it stretches across multiple availability zones, in order to make use of an availability zone, you obviously need to create your subnets, right? So if I just create a subnet in, let's say, AZ1 and AZ2, and I don't create any subnets in AZ3, then I'm essentially not making use of AZ3. I'm only making use of AZ1 and 2. But as you can see here, right now I have created subnets across all of the AZs, so I'm making use of all of the availability zones within the region. You can create multiple subnets within an AZ. As an example, I've shown here as a single subnet here, a single subnet here, but then I've created two subnets here, right? So you can create 2, 3, 4, how many ever you want. Of course, there are certain limits in how many subnets you can create and all of that. We'll talk about that separately. But then you can create multiple subnets within a single availability zone. And also, like I mentioned, you can create multiple VPCs within the same region as well, right? So don't think that you have to only create one VPC per region. You can have multiple VPCs. And as an example over here, I'm just using the AZ1 and AZ2 here. I'm not making use of the AZ3 because I don't have any subnets that are created. Now, let's look at all of the different core components of the VPC. Now, these are like almost the core essential components. There are, of course, a lot of additional components that come with this, but you kind of need these basic components to, at least make basic use of your VPC, or you kind of need to know what these are in order to kind of make use of your VPC. Of course, we talked about subnets, which is basically a division of your network, of your VPC network, into smaller networks or sub networks, which is what's called subnets, right? Now, you can have different types of subnets, like public subnets and private subnets, because remember, I showed you just in the other diagram, which is The reason you would want to have public and private is because you want to put your databases in your private subnet, because you don't want people from outside world to access your databases, but you want to have public subnets where you can put your application servers or your web servers or something like that. So you can have both public and private subnets. Now, the route table and the router work in combination, as you would expect. The router obviously routes the traffic just like how your router at your home works, but obviously it's a little bit more advanced than that. And there are route tables. So think of it like this. Let me just think of it like this. You will have the router sitting somewhere inside the VPC, okay? And then you will have a route table which defines how the traffic flows. So for example, if the traffic wants to, like, if for example you have an EC2 here and that EC2 wants to talk to the outside world, essentially it doesn't directly talk to the outside world, it will talk to the router, and then the router will look at the route table, and depending on what is written in the route table, it will decide how to forward the traffic, right? Guys, is my voice coming out clear? Like, is there any interruption? Is it dropping off or something, breaking up or something? Sanchit, is it all good?
Yeah, Faisal, we can hear you.
I'm seeing a little bit of a range issue. That's what I'm asking. Yeah, thank you. Okay, so those are your routers and your route table. Now you have your Elastic IP, which also kind of works in combination with your Elastic Network Interface, right? So think of it like this. Your Elastic IP is basically your public IP address, and your ENI is basically your network card, right? Where do you plug in your network cable? You obviously plug it into your network card, right? And it's your network card that basically carries that IP address. So think of this like a virtual network card that's connected to your, for example, your EC2 instance, right? We'll talk about what are the advantages of having it such like as a network card. As a quick example, let's assume that you have an EC2 which has an ENI connected to it, right? Which is a network card, and this ENI has a particular IP address, right? Now let's assume that something happened to this EC2, and is my screen blanking out in between? So let's assume that something happened to this EC2, and we need to now like have another EC2. So we set up another EC2, but then when we set up another EC2, normally you will end up having a different IP address, right? So what you can essentially do now is, if you have an ENI, you can disconnect this ENI from your existing EC2, and then you can kind of attach it to that EC2. So you will continue to have the same IP address associated with that ENI, right? So think of it like that. It's just a network card that is connected to your EC2 instance. Then you have your internet gateway. Now, like I said before, your internet gateway is kind of sitting at the edge of your VPC. So any traffic that is coming in or going out of your VPC has to go through the internet gateway. So this is like your IGW. So any traffic that is having to enter your VPC or leave your VPC kind of has to go through the IGW. So if you have a router here, and then you have a route table. So you have a router, you have a route table, and you have an IGW. So if an EC2 wants to talk to the outside world, the EC2 will talk to the router. The router will look up the route table, and then depending on how the traffic is configured, the router will, for example, forward this to the internet gateway, and then it will go outside, right? So this is kind of how things work. We will obviously talk in more detail about the routing, but internet gateway is essentially the it's kind of the service that lets you talk to the outside world, right? Any questions so far? All right. So after the internet gateway, you have the entire set of your customer gateway, your VPN connection, and your virtual private gateway, right? So this kind of works in combination. Now I will go back to the diagram which we showed. So remember these three things. This is your customer gateway, this is your virtual private gateway, and your VPN connection. Customer gateway, virtual private gateway, and your VPN. So let's go back to the diagram that we kind of showed before. This is your customer gateway. This is your virtual private gateway. And obviously, when you establish a connection between them, you're establishing a VPN connection, right? So the customer gateway is the router at your end, and the virtual private gateway is the router or the kind of the gateway on AWS side. And then when you make a connection between them, you're essentially establishing a VPN connection. Can we have a gateway? There's a question from Vaishnavi, which is, can we have, hold on. Can we have a gateway among multiple VPCs? Okay, we will talk about how you get connected, how you get multiple VPCs connected. There are other things other than a gateway. We'll talk about that. I think Dora has a question, which is, can have multiple ENIs to different EC2 instance. The short answer is yes, but there is a limit on how many ENIs you can get connected to a particular EC2 instance. It depends on the type of EC2 instance as well, right? But essentially, if you want to have multiple IP addresses for the same instance, you can actually attach multiple ENIs to the same instance, right? But sometimes even an ENI itself can support multiple IP addresses, right? So it's not just that an ENI will only support one IP address. So, okay, so we have another question. The connection between VPC and on-prem using VPN for customer gateway will be my firewall subnet. So in VPC, I define firewall subnet. So for firewall, how to initiate the traffic. Okay, so this, so Mohammed, I think you have actually gone a little bit more than where we are right now. So I will try to get to that section when we talk about VPNs and all of that. And obviously, like you said, you will also have like a firewall VPC or like a security VPC that you create, right? I'm just showing you a very simplified structure here, but we will definitely talk about that once we get to the VPN side. Okay, so your customer gateway, your VPN connection, your virtual private gateway, and then finally you have the main major component, which is the NAT gateway. So we talked about these different subnets, right? So we have a public subnet where you will put your EC2 instances, and obviously for your private subnets, you will put your database instances inside that. Now, private subnets by default, the reason they are called private is because anybody from outside your VPC cannot access the private subnets directly. Okay, this is not allowed. That's the whole point of a private subnet. You cannot directly access from the outside world. You cannot directly access your private subnet, and also the systems in the private subnet cannot talk to the outside world directly, right? This obviously is there so that there is no you can keep your private information private, and that your systems are not randomly talking to systems outside your VPC. But your databases do need updates, right? Your database systems do need to get updated. So how do they get updated if they're not able to access the outside world? This is where the concept of NAT gateway comes in. Think of it like this. You can get your database to talk to your EC2, which can then forward your communication to the outside world, right? You could do that. In fact, if you do this would be called a NAT instance, right? But then obviously the problem here is that you have to maintain this instance, you have to create this, you have to manage this, you have to update it, you have to manage the security and all of that. So instead of that, what you could do is you could replace this EC2 instance with nothing but a NAT gateway, right? So if you have a NAT gateway, this will control the access to the private subnet, which means it will allow the private subnets to talk to the outside world. Of course, you can put in certain conditions. It'll allow the private subnets to talk to the outside world. And if anybody is trying to initiate a connection, into the private subnet, the NAT gateway will kind of block that, right? That's the whole job of NAT gateway, that it wants to block external access going into the private subnet, but of course it will let the systems in the private subnet talk to the outside world. Now, of course, any communication that goes out, it will obviously allow the replies for that communication back in. So if that is like a reply for whatever the DB asked, for example, if the DB wanted an update and it talked to the outside world, and then the update gets downloaded, then that will work. But if anybody is trying to establish a fresh connection into the subnet through the NAT gateway, then the NAT gateway will block it. So this way you can still keep your databases private. If you do have any questions, please do post it in the chat. So these are our main components. Like I said, there are more components that we'll talk about as we go forward. But now let's move on to the next part, which is the concept of IP addressing and subnets. So this is a typical IP address. This is generally a Class C private IP address, but IP addresses are basically contain something called four octets. Like these are each an octet. And the reason they are called an octet is because each one of this are made up of 8 bits, right? So each octet is made up of 8 bits. So how many bits in an IPv4, guys? If each octet is 8 bits, and if there are 4 octets, how many bits is an IP address? IPv4. We are specifically talking about an IPv4. Anybody, quickly? Okay, I'm not sure why my screen is blanking out in between. The reason I say these are made up of 8 bits is because each of this number that you see here, for example, the 192, is represented in binary in this format. The 168 is represented in this form. The 100 is represented in this form, and the 201 is represented in this form. But you don't need to worry about all of this. But essentially, I'm just showing you that if you split it up, this is kind of how it's going to look. Now, obviously, since there are 4 octets and each of this octet is made up of 8 bits, you essentially get 32 bits in an IPv4. Now, this number is important because when we talk about IP CIDR ranges, we can kind of deal with I can show you how it's kind of broken up. Okay, I'm getting your replies, but I think it's extremely delayed, like I think more than a minute delay. So please do answer as soon as you can. Okay, so 32 bits of IP address. Now let's talk about CIDR ranges. Now just remember this number 32 and these octets. Each one of these octets are of 8 bits, right? In AWS, or mostly in most of the networking concepts, when you talk about IP CIDR ranges, you're going to basically write an IP in a particular format, which is going to tell you exactly how many IPs are there in that network and how large that network is. That's basically what a CIDR range is, okay? And this is how a CIDR range looks. So for example, I will say 10.0.0.0/16. This is the CIDR format. And it tells you exactly how many IPs are there in this network and how large this network is just by writing this. So instead of me having to write every single IP address in the network, I can just represent it in this format, which tells me how big it is. Now, how do I know how to figure this out? Here is where that number that I told you about, the number 32, comes in. So here you have a /16 represented here, and this number 16 is important. So if you want to figure out how large a network is or what are the IP addresses in that network, first you look at this number after the slash, and then what you do is you start counting from the left side, okay? What this is saying is that the first 16 bits of this network does not change. The first 16 bits of this network does not change. So when I say 16 bits, and if I start counting from the left side, the first octet is 8 bits. So the first octet does not change. Then I keep counting further, another 8 more bits. The second octet also does not change. So total of 16 bits are not changing. That's what this /16 means. What that also basically means is that the third octet and the fourth octet can be anything, right? It can be anything. So essentially, what's happening here is that I'm telling that the first 16 bits don't change, but the next 16 bits out of the 32 can change. So if I were to write down this IP address range, it would basically be something like 10.0.0.0 up till 10.0.0 255.255, right? This is the entire IP range in this one. Now, can somebody tell me what is an IP address in this? Can you give me an IP address in this range? Any single IP address within this particular range? Do post it on the chat. Um, Now, this tells me how large a network is and what are the IP addresses in this. Now, as you're posting the answer, I do have another question for you as well. Why is this always only up till 255? Why is it not 256, or why is it not like 300, or why is it not like 450 or whatever, right? Why is it always limited to 250? Can anybody quickly answer that? Yep, 0 to 256. But okay, so let me answer this question about why it's only 255. Remember, I showed you the bits that the bit breakup, like it's made up of 8 bits. If you actually need to write the number 256, you actually need 9 bits. Okay, this is why you cannot write 256 and above. Remember, each octet is only like maximum you can use is 8 bits. So if you need to write the number 256, you kind of need 9 bits. And of course, as you increase, the number of bits will also increase. This is why you have a maximum octet of 255. So just keep that in mind. Of course, this does not apply to IPv6. We are already talking about IPv4. Now, I asked the question about, can you give me an IP address in this range? I don't see any answers yet, but I'll give an example. 10.0.1.15, right? Or 10.0.3.99, right? You see the pattern here? The pattern here is that I'm saying that the first 2 octets are not changing. Only the third and the fourth octet will keep changing, right? So just remember, keep that in mind. When you're looking at this, keep that in mind, that when we put a 10.0.0.0/16, count from the left side, 16 bits are not changing. So the first 2 octets are not changing, and the third and the fourth octet can be anything. Okay, I do have a quick question for you guys. So if I have an IP address 192.168.0.0/24, can you please kind of expand this for me, just like how I have expanded this particular range for the 10.0.0.0/16, just like how I expanded this? Can anyone quickly expand this for me? 192.168.0.0/24. In the meantime, I'll just take that quick question from Dora Chowdhury. If we have any database patches or upgrades that we want to do, I mean, the time users will experience a downtime, how to overcome that? So that is like that's more on the upgrade maintenance side of managing your EC2s and managing a databases, right? It's nothing to do with networks. The network will just allow the communication. How you're managing that upgrade, actually, I think we discussed this in the databases section, right? Where we talked about how do you upgrade a database without causing any downtime, which is answer is basically your multi-AZ network, right? Okay, I don't see any answers yet for the 192.168.0.0/24. Anybody? Okay, I just want to point out here, I think a couple of you are not in the live. Like you, I think you're watching maybe like a minute back or something. So please hit the live button and make sure you're watching the session live if you can hear me right now. Okay, let me expand this for you. When I say /24, we need to count from the left side, and we need to not change 24 bits. So when I say not changing 24 bits, 8 bits, remaining is 16, another 8 bits, and remaining is 8, and another 8 bits. So basically what I'm saying is that 24 bits of the IP are not changing, which basically means the first 3 octets. So the first 3 octets are not changing, the last octet can change. So this IP address can be anywhere from 192.168.0.0 up till or 0.1 up till 192.168.0.255, right? And an IP in this range can be 192.168.16. Sorry, not 16. Because remember, the third octet is not changing. So this will always be 0. And this will be like 19 or something like that, right? So I hope this is a little bit more clear. Where we are basically writing a CIDR range, and we are pointing out as to how many bits in the IP address do not change. Based on that, you can define how large a network, how many IP addresses are there in this network, and then you can kind of decide how large a network is. Now, remember, when you put in the CIDR range, a /16 is actually a larger network than a /24. Okay, so keep that in mind when you say /16. Because when you say /16, you're saying that this octet and this octet does not change, but this octet and this octet can change, which means you can have 255 or rather 256 into 256 IP addresses, which is, I think, 65,536 IPs, right? Because in each of this, you can have 0 to 255, right? So you can essentially have 256 IPs with a total of 65,536. But when you say /24, it's only the last octet that is not changing. So this can be anywhere between 0 to 255, which basically means you can have a total of 256 IP addresses. So remember, depending on how you're defining your CIDR range, the size of your network will change. Harisha, so should we start from 1? So essentially, like I said, you should start counting from the left side. So number of bits, like each octet is made up of 8 bits, right? So let me quickly bring back this. So like I said, each octet is made up of 8 bits, right? So you start counting from the left side. When I say 16 bits don't change, you're basically saying that this octet does not change and this octet does not change, but this and this can change. So you're essentially saying that these two don't change, but this and this can change, right? So that's essentially what you're saying when you count from the left side. Now this number is not just /16 or /24 or something like that. It can actually be anything. It can be like /27, /19, etc. Right? But there are upper and lower limits. A VPC will always be between /16 and I believe it's a /27. You can't have VPCs outside this range. You will basically create VPCs within this /16 and /27 range. One last question that I have here. If I say 10.0.15.91/32, so when I put a CIDR range like this, essentially I'm saying that 32 bits don't change. What basically that means that none of these octets are changing, which basically means there is only one IP in this range, right? When I say all 32 bits are not changing, this is just one IP. So if you want to represent a single IP within AWS, you always have to represent it in this format, which is the IP /32. If you just put in the IP address, sometimes it might not work. So you need to kind of put in the /32 and kind of define that as a single CIDR range or a single IP. When you create CIDR ranges within AWS, you can create it under the RFC 1918 standard, which means you can use either of these classes. In the class A range, you can use this range. In the class B range, you can use this. And in the class C range, you can use this. But essentially what that's saying is that as long as your IPs are within this, your VPC will work. Couple of things to keep in mind. Some of the IP addresses in your network are reserved, which means you can't use that for your EC2s or your ENIs or anything like that, which is the .0, the .1, the .2, the .3, and the .255. So 10.0.0.0 is blocked, 10.0.0.1 is blocked, 10.0.0.2 is blocked, 10.0.0.3 is blocked, and 10.0.0.255 is blocked. So same thing, if you go with a 10.0, that .0 will be blocked. If you go with like a 172 or a 198, whichever it is, that range of IPs, these individual IP addresses are blocked. 0 is the network address, obviously, and 255 is a broadcast address. So you can't anyways use these two as it is. But apart from that, three more IPs that you cannot use is the .1, which is reserved for the router. So the router will always be in the .1. And then you have the DNS server, which is at .2. And then you have .3, which is kind of reserved for future use. Any questions so far? All right. Okay. I hope you understood the CIDR part. If not, please do put your questions there, because we are going to go into how do you break up a network into smaller CIDRs. So let's talk about subnets. So you have your VPC. As an example, I'm going to use this range, which is 10.0.0.0/16. And like I said, you will create your subnets within your availability zones, right? So whenever you're creating a subnet, you will have to place it within an availability zone. In this case, we have two AZs here, and I'm going to create like one public subnet and one private subnet in each AZ. So there's one public and one private subnet in each AZ. Now remember, your VPC is your main network that you're creating, and your subnets are your sub network of the VPC. Okay, so these networks, these subnets are basically within the VPC network. So whatever CIDR ranges that you're giving for your subnets has to obviously be within this range. Okay, so because this is your VPC range, so any subnets that you create will obviously have to be within this. So let me ask you this. If I create a subnet with a CIDR range of 10.1.0.0/24, is this acceptable? Will this work, or will this not work? So this is my main VPC range, and this is my subnet range, 10.1.0.0/24. The question is 10.1.0.0/24 within this range? That's basically the question, right? Is it not? So remember, when I say /16 for this range, I'm saying that 16 bits don't change, right? So if I start counting from the left side, 8 bits plus 8 bits. So this VPC, all of the IP addresses must be 10.0, right? Because I'm saying that the first 16 bits don't change, right? So obviously this subnet is starting with a 10.1, so it's definitely not going to work, because this is not within the same range of my VPC itself, right? So that's not going to work. However, I can definitely have something like 10.0.1.0/24. Will this work? It will, because the 1.0 is falling in the third and the fourth octet, and obviously the third and the fourth octet can change because only the first 16 bits not change. So as long as it's 10.0, I can have anything after that, right? So this way I will create a network of /24, which means inside this subnet, all of the IP addresses will always begin with 10.0.1. /24 means 24 bits don't change, so 8 plus 8 plus 8. So the first three octets don't change, right? So the fourth octet can change. So an example of an IP address in this will be 10.0.1.15, right? Or 10.0.1.200, right? So as long as it's 10.0.1, it will work inside this subnet, right? So if I create a 10.0.1.0/24 here, I obviously cannot create another subnet with a 10.0.1, okay, because obviously that's going to conflict with an existing network address, so I cannot do that. So I'll probably have to use something like 10.0.2.0/24, right? So this way I can create multiple subnets as long as it is a 10.0, because it has to be a 10.0 that belongs within the same VPC, right? So I can have a 10.0.4.0/24, 0.5.0/24, etc. Okay, so I can have multiple subnets like that, right? So as an example over here, this is the IP addressing that I'm going to use, and this is the one that I'm going to use when I create the subnets inside the VPC labs. Now, I did a 10.0.1.0 and 2.0 here, but then I went and did a 21.0 here and a 22.0 here. This is just for my own understanding, because as soon as I look at this, I know that the 21 and 22 kind of belong in a different AZ, and the 1 and 2 kind of belong in a different AZ. Just by looking at it, I can figure it out, right? This is not a rule. This is, you're just creating this for your own benefit, where just as soon as you look at it, you can kind of figure out, okay, these are not part of the same AZs. So if I want to put two instances in two different AZs, I know that 1 and 21 are different AZs. I don't need to go look, okay, is 2 in a different AZ or is 22 in a different AZ, etc. Right? So this is kind of how you will create out your subnets. There's a question from Kasukar, which is, what would be the max you can go for subnets? So remember, I told you within the VPC or the subnets, it has to always be within /16 to /27, I believe. I just have to double check this. I think it's either a /27 or a 28. I believe it's a /27. So as long as your IP CIDR range is between this, you can have it within your subnet. But do keep in mind, guys, remember I told you that 5 IP addresses are not usable, right? So this particular range, remember that these two octets can change. So essentially 256 into 256, I have 65,536 IPs, right? Out of this, anyways, 5 IPs become unusable because it's being used for the router and all of that. Okay, but remember, every time I also create a subnet, each time I'm losing 5 IPs. Okay, keep that in mind. Okay, so don't like create hundreds of subnets unnecessarily unless it's really required, because each time you do this, in each range 5 IPs are not usable. So keep that in mind. Each range 5 IPs are not usable. So essentially just these 4 subnets plus this VPC, I've lost what, 25 IP addresses out of this 65,536. I've already lost it. Okay, so just keep that in mind. And also do not create a VPC that is too small. Like for example, if you create a VPC that's 10.0.0.0 slash, let's say 26, right? So essentially what you're saying is that 26 bits don't change. Now I can show you how to calculate this, but I would rather tell you to use something like a subnet calculator, which I'll just show you in a second. So if you just go to Google and do subnet calculator, I would recommend you use the one jodis.de. And if I put in the same thing here, 10.0.0.0/26, so essentially I get only 62 IPs, right? So I cannot have more than 62 EC2 instances if I create a VPC that small. And if I go like /27, I only get like 30 IPs. So don't make your network too small, because then you can't actually change your VPC range. You can add additional CIDRs to your VPC. Actually, you couldn't do that before, but they made that new option where you can actually change. You can actually add a CIDR range, but you cannot change the existing range. Okay, so I believe the VPC cannot be more than a /28, not a /27, because the /28 is the smallest, which is 14 hosts. So your VPC has to be between a /16 and a /28. Okay, you cannot have a VPC that's smaller than that. Same thing with a subnet. Okay, so I hope this is clear. Any questions here, guys, before I move forward? Okay, just go to Google and type in subnet calculator, Harish, and there will be jodis.de IP calc. Yep, there is a formula. Okay, so let's move forward and let's talk about the routing, how the routing takes place within the VPC. So we have our VPC, we have our public subnet, and we have an EC2 which has an ENI. At this moment, this ENI has a private IP address which is 10.0.1.35, and we have another subnet which is 10.0.3.0/24, and we have another EC2 instance with another ENI with another private IP, and then obviously we have the router, and we also have the internet gateway, and then we have our route table. Okay, so these were the kind of main components that we talked about. So we have the subnets, we have the router, we have the route table, and we have the internet gateway. Now, how does the traffic flow? So let's take a quick example here. Let's say that this is system A and this is system B. Okay, system A wants to talk to system B. So 10.0.1.35 wants to talk to 10.0.3.48. So this system tells the router, I want to talk to 10.0.3.48. What does the router do? The router looks up the route table. Router looks up the route table. Is there an entry in the route table that matches this? Yes, there is. If you look at this, it says 10.0.0.0/16 is local. Now 10.0.0.0/16 is basically the entire IP of the VPC. So it's essentially saying that if the IP address is within your VPC, it's obviously local. So it's not going to send that traffic outside, right? Now, obviously your router knows which are the systems inside the VPC. So it knows where 10.0.3.48 is because it also maintains its own table of IPs. So it knows that, but it just wants to confirm whether it should send that outside the VPC or whether that communication is local. Now, since it's local, the router will then route that traffic to your other system, right? So this is essentially what happens. So as a second example, let's say that there is another IP address which is outside the VPC, and let's say this IP address is 52.16.91.3. Okay, so this is an external IP address outside the VPC. It's a system outside the VPC, and let's say system A wants to talk to that IP. Again, it will talk to the router. It will tell that I want to talk to 52.16.91.3, and the router will look up the route table. Is there an entry for that IP address here? Mohammed, you are actually not watching the session live, so if you can please hit the live button. I think you're probably like 5 or 6 minutes behind. So Mohammed, if you can hear me, just hit the live button. Actually, there is an entry for that IP address, which is basically this one. So 0.0.0.0/0 basically means any IP address. Okay, so any IP address, obviously 52.16.91.3 is part of any IP address, and it says it will send it to the internet gateway. So obviously it will send it out to the internet gateway, and then it will go outside. So I think you're confused now as to, hold on, if this is any IP, then this is also any IP. So why is it not sending it out to the internet gateway, right? So here's the thing about the route table. The route table always looks at the closest match. It really does not matter if you wrote this rule first and this rule second. There is no rule numbering in your route table, but instead it looks for the closest match. So if I, as an example, if I had another rule here that said 52.16.0.0/16 goes to IGW, this is, for example, a third rule, right? And it has to talk to this external IP address. So when the router looks up the route table, it will actually choose this rule instead of 0.0, right? Because this rule is a closer match than 0.0.0, right? So this is the reason why when you talk to 10.0.3.48, it actually chooses this one instead of any IP. The most closest match, it will use that, right? Any questions, guys, so far? All right. Um, let's talk about private route tables and public route tables. So in this case, we have two route tables. With one is a public route table and one is a private route table. As you can see here, what is the difference here? The difference is that the public route table has a route going out to the internet, but the private route table does not have that route. Okay. So if you're using the public route table, it can send the traffic outside and the traffic can also come back in. But if you're using the private route table, you can only talk internally. You cannot talk externally, right? This is useful if you're attaching a particular route table to a subnet. Now I want you to watch this. I'm going to attach the public route table to this subnet. At this moment, these subnets are kind of neither public or private. Okay, let's assume that for a second. It's only when you attach a subnet to a route table, it either becomes a public subnet or a private subnet. So watch what happens here. So I'm going to attach this public route table to the subnet and see how the subnet changes. So now this subnet has become a public subnet. Now if I attach this private route table to this subnet, then this subnet becomes a private subnet, because when I attach a route table to a particular subnet, if this subnet talks to the router for any traffic, the router will only look up this route table, right? It will not look up the other route table. Anytime the public subnet system wants to talk to the router, it will only look up this route table. So the route table that is associated with the subnet is what the router will look up anytime a system is trying to talk. So if this system now wants to talk to an external IP 52.16.9.3, if this system wants to talk to that outside world and says to the router, I need to talk to 52.16.9.3, the router looks up the route table. It does not see a matching entry for that. So it will just deny that or drop that connection, saying that, sorry, buddy, I don't see a way for you to talk to that outside world. So communication to the outside world is not allowed. This is what happens with a private subnet, right? So when you attach a private route table to a subnet, it becomes a private subnet, and then anything within that subnet cannot talk to the outside world because there is no IGW entry for that subnet. I hope that part is clear. But like I said, you can always get a particular EC2 to kind of forward the connection out to the outside world, right? So for example, I can proxy the connection through this system A, right? Like I still want to talk to 52.16.9.3, but this time I will tell the router, forward the traffic to 10.0.1.35. So it will forward the traffic there because it looks at the route table over here, and obviously it can talk. And then this system will forward that traffic to 52.16.9.3. So when the router looks up that route table, it has an entry to the internet gateway, and it will just forward that connection out the internet gateway. I mean, you can proxy this. This is when this becomes a NAT instance, right? But like I said, you don't want to do this because then you will have to end up managing this instance. So you definitely don't want to do that part. Instead, what you will do is you will use a NAT gateway, right? So what you're doing with a NAT gateway is inside the public subnet, you're essentially going to host a NAT gateway. When you create a NAT gateway, you kind of have to create in a public subnet, because if the NAT gateway needs to talk to the outside world, it has to be in a public subnet, right? It cannot be in a private subnet because then it cannot also talk to the outside world. But you see there's a slight difference here in the route table now for the private route table. If you look at it, the private route table now has a 0.00 entry, but then it goes to the NAT gateway. So now if it wants to talk to 52.16.9.3, when this system talks to the router looks up the route table, it does see an entry for 0.0.0, which is any IP, right? But it says that it has to forward that to the NAT gateway. So then it will forward that to the NAT gateway. And the NAT gateway actually has the software or the program to do exactly this, which is forwarding, right? Or proxying, basically. So now the NAT gateway will forward it to this IP. So it talks to the router looks up the route table. It sees there is an entry for that to the outside world. It will forward that to the outside world. Clear, guys, what a NAT gateway does? But remember, if somebody tries to establish a connection into the NAT gateway, then the NAT gateway will block that. Okay. unless the NAT gateway had initialized that connection. If somebody is directly trying to talk inside the NAT gateway, that's not going to work. The NAT gateway is going to block it. Any questions? Okay. I think not questions. Okay, just a few clear points to remember here. VPCs are always within a region, but they do stretch across the AZs. There are subnets that can either be public or private, but the subnets are always within an AZ. Okay, this is why when you launch an instance, when you say you're launching an instance into an AZ, you are essentially launching an instance into a subnet that belongs inside an AZ, right? So if you need to kind of launch an instance into an AZ, you already have to have a subnet that is created in that AZ. Otherwise, you can't launch an instance into it, right? Subnets must be associated with route tables, so you should either associate it with a public or a private route table. Then you have the internet gateway, which is where all of the traffic flows in and out of the VPC. Then you also have a NAT gateway, which if you want to use it for your private subnets to talk to the outside world, you can use that. There are 5 IP addresses that are not usable or reserved, which is .0, .1, .2, .3, and .255. And the VPC has to be within the /16 and the /28 range. This also applies for your subnets. It has to be within 16 and /28. Now, if I create a /16, just to quickly show you, if I have a 10.0.0.0/16, I cannot have another subnet which is 10.0.0.0/16, okay, because it's using up the, it's basically conflicting, right? I cannot use up that entire thing. I have to use something a little lower than that, okay? Again, you can have a single subnet that uses up all of the IPs if you want to do that, but don't do that. The reason of having subnets is because so that you can split up your networks into smaller networks. Okay, VPC peering is where essentially you are connecting two VPCs together. Okay. There are other ways you can connect two VPCs together. For example, you can have like a VPN software that is running on two different instances, right? And you can establish a VPN connection between these instances. So if anybody wants to talk to each other, they can go through these VPN instances. That's how you used to do it before. But then you don't need to do that anymore because there is something called a VPC peering connection, right? Essentially, what you're doing is in a route table, you are creating an entry. For example, look at this IP address range. This is 172.31.0.0/16, and this is 10.0.0/16, right? So all of the systems in this range will be 10.0, okay? And all of the systems in this range will be 172.31. So what you're essentially just doing is once you establish this VPC peering connection, there is a service called VPC peering, which you have to get the VPCs to peer using that service, which I'll show you in the labs. So once you do that, technically what is happening is you're just creating a route table entry. Because if you look at this, inside the 172, you will create a route entry which says if any traffic is destined for 10.0.0.0/16, send it to the peering connection, right? So whenever these systems want to talk to 10.0, it will obviously send it through the peering connection, which once it goes to the other side, it's local, right? Same way, if these systems want to talk to the other systems in 172.31, you mention that in the route table under the peering. So that will be sent out to the peering connection. And once it reaches this side, that communication is local, right? I know this is a little bit too simplistic, but essentially that's what's happening when you establish a VPC peering connection. But there is a problem that comes up with VPC peering is if you have more than one VPC and you want to peer them, this actually becomes a nightmare. So if you want A to talk to B and A to also talk to D, if you just create a peering here and here, it's not going to work, because within VPC, the transitive routing doesn't work by default. Okay, transitive routing means you're taking one route, going to another VPC, and then using another route to go to another VPC. That doesn't work. Okay. Instead, what you have to do is, if you need A to talk to D, then you also have to create a peering connection between A and D. Technically, what's going to happen is, if you need all of these VPCs to talk to each other, you need to create peering connections across uh, yeah, you need to kind of almost like create a mesh connection where you're creating multiple peering connections. And this can become quite a nightmare to manage if you have like 10-15 VPCs, because imagine the number of peering connections you have to do, and imagine the number of route tables that you have to update with all of the correct IP addressing, right? To address this issue, they brought in something called a transit gateway, where essentially this becomes like a centralized router to transfer the traffic between the VPCs. So instead of you creating multiple connections between your VPCs, you will just have one connection to the transit gateway. So you will have a route table which will have routes, where you will basically say anything belonging to B will obviously be local, and anything belonging to C, anything belonging to D, anything belonging to A will go to the transit gateway, right? You'll just basically create that in your route table. So now you have a very clean route table that you maintain across all of these VPCs, because you don't have to like create multiple route tables that go to multiple connections, etc. So you essentially get a more cleaner connection. Kasukar asks, there's a question from Kasukar, is there a data transfer cost within a VPC peering connection? Yes, I believe there is a transfer cost, but I think the transfer cost mostly comes from whether you're because let me tell you this, transfer costs within AWS is very tricky. Okay, because the cost kind of depends whether you are actually doing inter AZ transfer, or whether you're doing inter region transfer, or whether you're using public IP transfer. For example, if I have as an example, okay, let's say that both these systems have public IP addresses. Okay, this system has 52.16.9.3, and this has, let's say, 61.2.39.4. Okay, let's say these both have public IP addresses. Now, if I actually talk from public IP to public IP, this data transfer, how it works is, it has to go out through the internet gateway, and then it has to come back in through the internet gateway and then connect. Okay, so the cost is different if you actually talk using public IPs versus you talking with private IPs. And also the fact that if you're doing inter-AZ routing versus region based routing. So truth be told, there is no direct answer like exactly how much is going to cost you, because it will depend on how much how you're transferring it. But yes, there is a cost associated with it. Okay, I think we've done too much of theory. Let me quickly jump into the labs and show you a little bit of setting up VPC. Give me a quick second. All right, let's have a quick look at how we're going to set this up. So what I'm going to do in this lab, guys, is pretty simple. I'm going to create a VPC. I'm going to create some subnets, and I'm going to create a route table, create an internet gateway, and I will later on show you how to connect your instances inside the VPC. And there are some additional topics within the labs which I will cover, like VPN and NACLs and all of that. There is a little bit more to cover in theory. Once we do that, I'll cover those labs. But for now, what I'm going to do is essentially I am going to set this up. Okay, so this is what I'm going to do. I'm going to create a VPC with the IP range of CIDR range of 10.0.0.0/16, and I'm going to create 4 subnets that belong in 2 different AZs. And this will be the format where I create one public subnet and one private subnet in AZ1, and I'll create another public subnet, another private subnet in AZ2. So if you want to take a screenshot of this, please do that right now, and I will be switching to the labs and doing this exactly the same thing. All right. So you will always have a default VPC that is available within your environment. Okay, normally it doesn't have a name. So that will always be like 172.31.0.0/16. So never delete this default VPC, because this default VPC will always work, right? So if you want to always test something, whether it's a network issue or something like that, you can always just use the default VPC and it's almost 100% always going to work. So don't delete this, don't modify this. Unless of course it's a production environment and you want to like delete it. Okay, but ideally speaking, just leave it around because you will need to use it a little bit later on. I think I have another one here. Let me just switch regions. Give me 1 second. Okay, so every region there will always be a default one. Like I said, don't delete that. So let's go ahead and create a VPC here, and I'm just going to call this as labs, and here the IP range will be 10.0.0.0/16. And if you want, you can also get an IPv6 range along with this. So you would want to select IPv6 assigned by Amazon, but right now I'm not going with an IPv6 right now. Leave the tenancy at default, because if you go with dedicated, your cost is going to increase exponentially, because they're going to give you dedicated like hardware that will only be used by you for the network, right? So don't do that. So I'm going to create that VPC. So my VPC structure, like the basic outline is created, right? 10.0.0.0/16. So now I need to create some subnets. Now these are the default subnets that are part of the default VPC. So I'll not do anything with that. I'll just click on create subnet. I will select the labs VPC that I just created, and I will call this as public 1A, because I intend to create this inside AZ1A. So I will select 1A here. Okay, so the AZ I'll select as 1A, and this will be 10.0.0.0 slash nope 1.0/24. Remember, I am using this format. Okay, so I'll use 10.0.1.0, 2.0, and 21.0 and 22.0. So this public will be 1, private will be 2. Here public will be 21, and here private will be 22. And that's that. I will add a new subnet, and I will call this private 1A. Put that in 1A, 10.0.2.0/24. Add a new subnet. I will call this public 1B, because now I'm putting it in the 1B sub AZ, right? 0.21.0/24. One more subnet, which is private 1B. Now, just because I'm calling these subnets private and public, do they become private and public just because I'm calling them as private and public? When do they actually become private and public? If I just name them as private and I call them as public, does it mean that they are private and public? They are not, because there's something else I have to do. So here are the 4 subnets that I created, and I named them as public 1A, private 1A, public 1B, and private 1B, right? And that's that. So as far as route tables are concerned, there will always be a default route table when you create a VPC. Okay, so for example, when I created this labs VPC, it will by default create a route table that belongs, as you can see over here. Okay, this will by default be a private route table. Okay, so when you create this, it will by default be like a private route table. This is what will get associated with all of the subnets that you create. Okay, uh, and if you create an internet gateway, that will automatically also get added over here. But I don't want to use this default one. I will create my own route table. Okay, so I will, but before I create my route table, I need an internet gateway. Okay, so I will go to internet gateways. I will create an internet gateway because I need to enter the internet gateway in my route table, and I will call this as labs IGW. I'll create an internet gateway, and it's created. Now after you create it, it will be in a detached state, so I need to basically attach it. Now one thing to be careful here is, if you, for example, let me just refresh this. If for example you're in your VPC or your subnets, and here you can see all of your subnets belonging to all of the VPCs, right? But if I want to filter out, I can actually select the labs VPC that I just created, and I can filter it out, which means I will only see resources that are associated with my VPC. Okay, but when I go to internet gateway, I do not see the internet gateway that I just created. This is because I have not yet attached it to my VPC. I only created it, right? So you need to remove the filter. And then here is that gateway that I created. And right now, as you can see, it's in a detached state. I will attach this to my VPC, and I will select the VPC. Okay, so don't be startled if you come to internet gateways and you don't see the internet gateway that you just created. That's most likely because you haven't yet attached it to the internet gateway. I'm sorry, to the VPC, right? Okay, so my internet gateway is created. So now let me go create my route tables. I'll create a route table, and I will call this as public RT route table. I will select the VPC. I'll create route table. I will also create one more route table. I will call this private RT, and I will select my VPC, create route table. Okay, and they're called as public and private route table. Again, just because I have named them as public or private route table, they do not become public or private. Okay, so if I go to the public route table right now, if I go to the public route table and then I go into routes, is this route table right now public? Can you look at the routes and tell me if this route table is right now public? Because if you remember, the public route table and the private route table looks like this, right? So at this moment, even though I've called it public, is it actually a public route table right now? Murli says yes, but is it? Is there a route out to the internet gateway? Do you see a route out to the internet gateway? Because you can see here it's only 10.0.0.0/16 local, right? In a public route table, you also have to have an entry into the internet gateway, which is actually missing in the public route table right now. So right now, although I've named it as public route table, it is still a private route table because there is only a local route, right? So as you can see here, there is only a local route. There is no public route. So in order to add the public route, I will go to edit routes. I will add a route. I will say 0.0.0.0/0, and this I will send to the internet gateway, and then I will select my internet gateway, and I will save the changes. Now you can see there are 2 routes, one which goes out to the internet gateway. Do I need to add this in my private route table as well? Do I need to add this entry in my private route table as well? Should I add it? The short answer is no, because obviously I don't want any system accessing the internet using the private route table. But right now I'm at this stage, which means they aren't associated with a subnet. Only after I associate them with subnet will the subnets actually become public or private subnets. Okay, so this step is missing. I need to basically associate them with the subnets. Okay, so I'll do that. I will go to the private route table first. I will go to subnet associations, and then I will edit subnet association, and I will select private 1A, private 1B, and I will save it. Same thing I'll do. I'll go to public route table. I will go to subnets associations, edit subnet association. Then I'll say public 1A and public 1B, and I will save this. So as you can see now, it shows that the two subnets are associated with the route tables. Now, if I do not do this, the subnets will automatically get associated with the default route table. So whatever is there in the default route table, it will use that route. Okay, which I don't want. As you can see here, default is basically the one that says yes for the main. And this one actually just has a private route right now. So yeah, so I don't want that. I now have associated them with the correct ones that I need. Any questions so far? So we have created the VPC, we've created the subnet, we've created the route tables, we've created the internet gateway, and then we have associated the internet gateway as a route inside our route table, and then we have associated our route table with the subnets. Okay, the NAT gateway part, the NACLs, and the VPN. I will come back to this because we do have a little bit more to cover. So I'll come back to this and I'll show you how to set that up. But essentially, creating a NAT gateway requires that you put the NAT gateway in a public subnet. That's basically what it is. Okay, and the NAT gateway also needs an elastic IP. Because the NAT gateway needs to talk to the outside world, so it needs a public IP. So two things that you will need when you create the NAT gateway. But I'll come to that in a second. But let's just quickly move forward and let's talk about ways you can get your on-premises connected to AWS. So there is this option called AWS DirectConnect, which is kind of exactly as the name suggests. It is a direct connection into AWS. So on the left side, you have your on-prem, and on the right side, you have AWS. And if you want to have a private connectivity from your on-premises directly into AWS, you can make use of the DirectConnect connection. Now, it's not a service that you just activate and start using. This is, think of it like this. This is a direct physical connectivity between your on-prem and AWS. So there is like a physical connection that goes between your on-prem as well as AWS side. This is made possible using DirectConnect partners that are there. Now, in some cases, AWS already has the infrastructure around, so they will kind of give you the connection directly. But in almost all the cases, you will have to go through a third-party provider that is basically a DirectConnect partner. Now in India, this is, I believe, Airtel, and I believe there are a couple of them, like Airtel and Reliance is also, I think, part of a DirectConnect partnership. So you can basically, no, Airtel and Tata, I believe. Yeah, Tata Telecom. So you'll basically use one of these providers to get a direct connect access into AWS. So they will kind of lay the physical cable from your on-prem and they will connect it into the direct connect location. This is where you will basically do a cross connect between your side and the AWS side. Okay. Now, this is, as the name suggests, a direct physical connection. So you almost always have a private connectivity, so you don't have to like establish a separate VPN. Of course, you would want to still do that because you still want to privately ensure that your data is 100% secure. But this is already private, which means this is not going over the internet. Okay, so this is a private virtual channel, or this is like a private physical channel that you get. So you don't need to like create additional virtualization on top of it. in order to have a private connection. Like, you don't need to do a VPN connection. However, the costs can be a little bit higher because of the fact that somebody has to physically get you connected into AWS, and there are different types of speeds that are available, like a 1 gigabit per second, 10 gigabit per second. And of course, if you don't have that kind of money to spend, they do have lower plans, but those will be like shared plans. So there are like 50 megabit per second shared plans as well. But it's essentially the providers, it's up to the provider whether they give you that or not. So not in all locations you will get that option, because the direct connect partner might already have some equipment in the direct connect location which is kind of free, and there are some shared ports that are available. So they might allow you to connect into those shared ports at a lower fee for a lower speed, but it's not always a guarantee that you will get it in every location. This requires you to first get an LOA or a letter of authorization from AWS, which then you will go and give it to your direct connect partner, and then they will start the process of laying the connection. But this is something that you will definitely have to choose if you are like an enterprise, because this will be more cost effective over the longer term, because you don't actually pay a lot of internet data transfer rates. Because if you're using internet and then you're using VPN over it, remember, your data is still charged for every single gigabyte that you transfer, right? So there is like a higher cost associated with using the internet and transferring data compared to using a direct connect connection where you have several terabytes of data that you want to transfer. I mean, if it's a few gigabytes, it might look expensive, but when you're talking about the longer term, like several gigabytes, this can actually turn out to be cheaper. Now, if you do not want to use a direct connect, or if you do not have the payment deep pockets for the direct connect, there are other options which I will discuss in a second. But before we go there, let me quickly discuss VPC endpoints. So remember, I told you that any data that has to go outside your VPC has to go out through the internet gateway, right? Now there are services like S3 and DynamoDB, etc., which your EC2s need to talk to, right? Now these services are not inside your VPC, right? They are on AWS, but they're still not inside your VPC. And internet gateway basically means that the traffic is moving from a private network into a public network, right? That's essentially what internet gateway is. This is a private network that's controlled by you, and outside your VPC is a public network that's not controlled by you. Of course, this is still an AWS network, but it's not your network. It's still a public network. There are other people transferring data using this network, right? So what happens is, you might be transferring secure data across to S3, or you might be wanting to fetch data from your DynamoDB securely, which you can use HTTPS endpoints that are already there. But then HTTPS, it's not like still in VPN level encryption, right? So there is always this risk where you are transferring data from private to a public network when you're using internet gateway. So in order to avoid this issue or overcome this issue, AWS brought something called VPC endpoints. VPC endpoints basically have a private connectivity between the service. So this is actually a private channel, okay? Think of it like a VPN, okay? Not a VPN, but think of it like a VPN, where there are endpoints that you can create. Like, for example, I can create one endpoint for S3 and I can create another endpoint for DynamoDB. And when I do this, my instances, instead of using the internet gateway, will now use these endpoints so that they can actually talk to the service privately. Okay, so this is what endpoints are for. You can privately talk to something like S3 or DynamoDB. At this moment, endpoints are available only for S3 and DynamoDB, because this was actually bought out a long time ago. Later on, a newer option came in, which is known as interface endpoints. So for almost all the other services, it's exactly the same idea here, that you want to talk to those services securely, but instead of having like a endpoint or a gateway endpoint, you're having an interface endpoint, which is basically an ENI or a network card, right? So each service now gets its associated network card. So if an instance wants to talk to a service, it can just talk to that IP address that network card belongs to, right? So this ENI, this network card, like I said, it will have an IP that is associated with that. So each service will have like a IP range that each of these network cards will have, and you can essentially have private communication with those services even though these services are outside your VPC and they are part of the AWS network, right, which is a public network. So if you want to securely talk to your services, either use VPC endpoint for S3 and DynamoDB or use interface endpoints for all of the other services. Any questions? I hope all of you are not bored, and because I know it's 1.5 hour of session going on right now and it's a lot of information. I hope it's understandable for everyone. Okay, let's move on further to additional security and logging information. Let's talk about NACLs, security groups, and flow logs. So there is a difference between NACLs and security groups, but essentially both of them are kind of the same idea, which is you're protecting the resources behind them. Okay. The only difference is that the security groups work on a resource level. Okay. So when I create a security group, it's protecting it on a resource level. Okay, so for example, if these are my EC2 instances, the security groups are protecting that resource itself. Okay, but a NACL protects you on the subnet level. So the protection for the NACL applies on the subnet level and the security group applies on a resource level. I wouldn't say an instance level, because you can apply security groups on other things like databases, right? Or load balancers. So security groups are always on a resource level, not an EC2 level per se. But of course, an EC2 is also a resource. Now, the idea here is that there's a little bit of a difference in how NACLs and security groups function. But let's first look at how security groups function. So I have two security groups here. Okay, which is security group 1 twice, and then the second security group, which is SG2. Okay, so I have two security groups here. These two are the same security group. Now I have three instances, A, B, and C. Now remember, even if I create two resources and I assign them the same security group, okay, they are still protected individually by the security group itself. What I mean to say is that if I create A and B and if I assign both of them to SG1, it does not mean that SG1 will protect them like this. Like everything is not protected inside a single SG, right? Each resource will have the same SG protecting it individually. And this is important to understand, because when you talk about communication between SGs or between resources, this is very important to understand. Security group communication by default is allow all outbound and deny all inbound. This is the default security posture for your security groups. Okay, so your security groups will always allow all of the outbound communication, but will always deny all of the inbound communication. So what you have to do is, if you want to allow certain communication inbound, you have to start opening ports, right? So if you want to allow port 22, you have to kind of specifically open port 22, because by default it denies everything. Okay, you don't really do anything on the outbound, because outbound is anyways allowed, so you don't really change that much. But if you want to specifically allow a certain port inbound, you have to open that port. Now, why does this matter? Because let's take an example. Let's say that security group, let's say that instance B wants to talk to instance C. Now, these both belong in different security groups, SG1 and SG2. B in SG1, C in SG2. Can you tell me where should I open the port? Like on which security group should I open the port? Should I open the port on security group 1, or should I open the port on security group 2? Keeping in mind that security groups by default is allow all outbound and deny all inbound. So do I have to open the port 22 on the security group 1 or security group 2? quick. Right, we have to open the port on security group 2 because remember inbound is always denied, so I have to specifically open port 22 on SG2. So it will be something like this, where the SG2 rules will be inbound port 22 and the source is SG1. Okay, so I can of course specify the source as the IP address of this particular instance, but I don't want to do that because there might be other instances that belong as part of the SG1 that also wants access to C. So I just need to mention the security group. If I mention each instance, then it will become a problem because then I have to kind of put each instance inside the security group rule, which I don't want to do. Okay. Now, what if C wants to talk to B on port 443? I essentially have to create this rule in SG1, and I'll create a rule which says inbound port 443, and the source will be SG2 because the communication is being initialized from SG2. And if I have a communication from SG1 to SG1, so I am talking to instances belonging to the same security group, A to B. Do I need to open a port or do I not need to open a port? If I want system A to talk to system B, do I need to open a port? The answer is yes. I need to still open the port because remember, when I told you that when you create the resource, it's not like it's creating it and then putting it all under the same group. No, it's individually protecting it. What that means is even if A wants to talk to B, the idea is that it's leaving the security group and then re-entering the same security group. Okay, so you still need to open the port, okay, because it's leaving the security group and re-entering the security group. So I will still have another rule here that says inbound port 80 for SG1. Even though it is still SG1, I'm still creating this rule in SG1. I still need to allow SG1 to talk to itself on port 80. Otherwise, systems belonging to the same security groups will not be able to talk to each other on port 80. And of course, even if I do this, I still need to open that port 22 for that security group. And then finally, this other rule, which is SG system A wants to talk to system C on port 8080. I still need to go to SG2 and open the inbound port and create a source as SG1. Now, one thing to remember here is that, for example, I am talking on port 22 to C, and if C is replying back on port 22 for that same communication, if it's replying back, I don't need to open a separate port here, okay? Because the security groups actually remember where the transfer happened or where the communication happened, which basically means it is stateful. Okay, that's the word I was looking for. So security groups are stateful. They remember where the communication happened. So if you talked on port 22 to another system, if the communication comes back in on the same port, you don't really need to, or if it comes back in, even if the port number is not the same, if the reply comes back in, you don't need to open a separate port for that. Okay, because sometimes the replies will come in different ports, not the same port. Okay. The network ACL works a little bit differently. In fact, let me just show it to you right here. The network ACLs work a little bit differently. Here in inbound and outbound rules, it's completely dependent on rule numbers. Okay. Let me show you this. Okay, in a NACL, unlike your security group, rule numbers define how the traffic flows. Okay, so if I have a rule 100 which says allow all that will ideally be my first rule. Okay. Then I can create another rule, for example, say rule number 150, which says block port 22. Okay. So this is processed like this. Okay. Rule wise. Will this block work? Like I have rule number 1 or rule number 100, which is allow all, and then I have another rule 150, which says block port 22. This will not work because in the first rule it is already allowing all of the communication, so this second rule will not get triggered. Okay, the first rule already allows it. So ideally you still want to have an allow all rule, but you probably want to put that as the last rule. Okay, so you definitely don't want to do that as the first rule. You want to do that as the last rule. So I will have, let's say, rule number 100, which says block port 22, and I'll have rule 150, which says block port 25, and then I will have a rule 200, which says allow all. Okay, so this way I can confirm that 22 is blocked, I can confirm that 25 is blocked, and then anything that is not blocked will be allowed, right? Because it processes the rule wise. So in NACL it's always rule wise, it will process it like that, so you can have multiple rules. The reason you want to actually leave some gap between the rule numbers, for example, I've used 100 here, 150 here, and 200 here, is if you want to have a rule in between this, you can now have it. So I can have another rule like rule number 125, which says block something, whatever port I want to block, because if I don't leave a space here, I basically have to rewrite all of the rules every single time, right? So I don't want to do this where I'm creating rule number 100, 101, 102, 103, 104. Like I don't want to do that, because then if I want to change anything in between, I basically have to redo the entire thing, right? So leave some space between the rules that you create in a NACL. Okay. So unlike your security groups, your NACLs go rule wise. Your security groups just look at whether that port is allowed or denied. Okay. That's what your security groups do. So your security groups operate on the instance level or the resource level, and your network ACL operates on a subnet level. Your security groups do allow only rules. In your network ACL, you can do both allow and deny rules. And this actually works. You have to do it separately for the inbound and outbound. Because remember, I told you security groups are stateful. So if you send some traffic outside, it remembers where that traffic went, and any traffic that comes back, it will still allow it, even if you don't open that port. But in network ACL, that does not work. You still have to separately open the ports for both inbound and outbound. Okay. So if you send traffic out on port 80, and then if there is traffic coming back in as a reply to that traffic, even if it's on port 80, right, you still have to explicitly allow that in the inbound rule. Otherwise, it's not going to work. Security groups, it looks at all of the rules before it decides. But in network ACL, it looks at rule number wise. So first one, if it's blocked, it's blocked. It won't go further than that. The security groups allow, like they will apply it on the instance level. So when you when you create an instance, you have to specify the security group, right? But when you create an instance, you don't specify the network ACL, because when you create an instance, you will put that instance in a subnet, and that subnet will already have an ACL associated with it, right? Network ACL. So you don't specifically select an ACL when you start an instance. Okay, I hope that part is clear. One thing that I wanted to say about flow logs is if you want to monitor the traffic that is going in and out of your VPC, it's pretty simple. You just have to enable the flow logs for your VPC, which I can show you if I can find it over here. Yep. So you can create a flow log for your VPC right here, which if you do, it will basically log all of the inbound and outbound connections that are coming in. It will show you whether it was denied or allowed, etc. Okay. So I hope that part is clear. Now, a couple of things like the VPN. Let me just quickly run through because we still have domain to cover. So I'm hoping to finish domains as well today. We have probably approximately another, I think another 40 minutes maybe. So yeah. So let's talk about VPN. There are multiple ways you can connect VPN to AWS. You have the option of hardware VPN. This is that first example that I showed you where you have a customer gateway, which is the router on your side. You have the virtual private gateway on AWS side, and then you're establishing a VPN connection between that. This is known as a site-to-site IPsec connection, where you're connecting two sites together, which basically means you're not using any VPN software to connect. Like you're not dialing in, right? So that's basically what a hardware VPN is. It's already connected on a hardware level, like router to router. It's already connected. So you're not having to do any additional dialing into VPN or something like that, right? But with a software VPN or a client VPN, you essentially have to do that. You kind of have to dial in to a VPN. Okay. Okay, just before I go forward, let me look if there was any questions that I missed. I think I did. Okay, I think there's one question from Harish, which is one security groups can be split into how many number of security groups? Well, you're not splitting the security groups, Harish. You're basically reusing the same security group with multiple instances. That's essentially what you're doing. You can create one security groups and you can use it with how many other instances you want, right? So you're not splitting it up. Security groups maintain any logs. This will mostly show up in your flow logs, whether a connection was blocked or dropped. But also, you can of course enable CloudWatch logs if you want to do that. But security groups itself does not have like an inbound logging, built-in logging function. You can basically make use of CloudWatch as well as flow logs. Okay, I think Mohammed just did add some additional information there, which is when you create your flow logs, you can look at how specific you want, your flow logs to look. So there are multiple options that you get to choose from. Like mentioned in the comment there, if you do it per VPC, it'll be more specific. If you do it per subnet, it'll be very specific. And of course, if you want to look it on the interface level, right? So remember, you can log it on the ENI level, you can log it on the subnet level, and you can of course log it on the VPC level. Thanks for that, Mohammed. All right, let's continue with the VPN part. Okay, so there's hardware VPN and then there's software VPN. On the hardware VPN, it's you need to have a VPN capable router which you can connect with AWS. On the client VPN or the software VPN, you do have two options. Actually, a couple of years ago, you did only have one option, which was the open VPN or the third-party client. But then recently, I would say, I think about 2 to 3 years ago, AWS came out with the option of client VPN endpoint. So let's look at what these are. So a hardware VPN is going to use some sort of physical hardware. So it'll be a router that is capable of establishing an IPsec connection. So just like how I showed you in our initial diagram, there will be the customer gateway, which is basically the router and the customer premises. There is a VPGW or the virtual private gateway on AWS side. And then you establish something called site-to-site VPN. All right. Then you use the transit gateway to obviously connect multiple VPCs together rather than having VPC peering. So this is your hardware VPN part. Now let's talk a little bit more specific about the client VPN endpoint, because I can't show you a hardware VPN right now, but I can actually show you this in the labs. So with our client VPN endpoints, you basically have your VPC and you have your subnets, and you will create something called a client VPN endpoint, and you will associate it with a subnet. Okay. So you'll create the endpoint and then you'll associate it with the subnet. I believe some of you who might have seen the session that I did for storage, I actually made use of this client VPN endpoint at that time, where I was connecting with VPN into AWS to map my network drives that I had created at that time. So it's kind of something like that, right? So then you have either your on-premises or at home, wherever you are. You can essentially use some kind of a VPN software. You can either use AWS's own VPN software that they give, or you can use something like an open VPN client, which essentially you will dial in or you will connect in, and now you have a secure access to whatever is there inside these subnets. So even if these subnets are basically private subnets without any public access, you can still access them because now you are connected into AWS via VPN. So you are already on a private network, right? So you don't need a public IP, you don't need an internet gateway to actually access those systems. So you can probably connect directly to your databases. That's your client VPN endpoint. Now, there is the option of a third party VPN service, something like OpenVPN. But in order to do that, you will basically have to run that third party service as an EC2 instance, right? So you will create an EC2 instance with that software installed on it as the instance starts up, or you can just start a normal EC2 and then install it after you create the EC2. However, it's the same concept, but this time with the third party VPN server, you do have a slightly different option, which is that you can still establish a site to site VPN. Okay, so you can still have a physical router connect to your third party VPN server. Okay, you can't do this with a client VPN endpoint because you have to kind of dial in using AWS client VPN endpoint, and it doesn't work the other way where the systems inside your VPC can't talk to the systems inside on-prem. So that doesn't work with your client VPN endpoint because it's specifically for connecting into AWS only, right? It's not a site-to-site VPN. But if you're using a third-party service like OpenVPN, you can actually establish a site-to-site VPN, but you can also establish the general dial-in VPN as well. Like if you're sitting at home and you need to connect in, you can still do that. You can still establish a dial-in VPN, right? You can do both. So the difference here is just that, which is you're using a client VPN endpoint and you're using a third-party VPN service. It's almost the same, except that one is provided by AWS and the other is you are having to set it up yourself. Any questions on this? Okay, I will show you the VPN. Let me see if I have an EC2. Okay, if time permits, I will definitely show you the the VPN. But I do have an assignment for you. So there is a choice for you. You can either do the lab assignment A, or you can do the lab assignment B. Okay, I would recommend you definitely try out the B instead of the A. The assignment A is where you have to create a client VPN endpoint which connects to a private subnet which has an EC2 inside it. Okay. Whoever does this and sends us a result showing that you've done this, we will do something for you. Okay. It might be some credits, or it might be your chance to actually come to the top of winning the exam voucher. So try to do this. Okay. You have your assignment 1, which is you just creating the client VPN endpoint which connects to a subnet. The other assignment is you have 2 separate regions. You have 2 separate VPCs. You have 2 separate private subnets in those separate VPCs. You are creating a VPC peering connection between them. And you are basically connecting like this. Okay. So you should demonstrate that you are able to connect to the other EC2 in the other zone using a client VPN in this zone using VPC peering. But anyways, I'll show you both of this part where I create the client VPN endpoint as well as a peering connection. Okay. So let me actually do that right now. Let me just show you the peering connection. So one important thing to remember is that when you're peering 2 VPCs together, they cannot be of the same CIDR range. Okay. So if you have a VPC here of 10.0.0.0/16, and let's say you have another VPC in another region, they cannot be in the same IP range. Okay, they have to be different CIDR ranges. Okay, so here what I'm going to do is I'm going to establish a VPC peering between Mumbai and North Virginia. I think I have another VPC there, or in fact I'll do that. So what I need to do is I will go to peering connections. I will create a peering connection and I will call this labs peer. Okay, so there is always a requester VPC and there is an acceptor VPC. Okay, now this is only relevant when you are doing it between 2 different AWS accounts. Okay, because there will be one account that is requesting it and one account that is accepting it. But normally, if it's within your same account, then you are both the acceptor and the requester, right? But this is relevant when you are connecting into a different account where someone else is actually the acceptor, where you're sending a request. So here, the requester is my VPC over here. Okay, and the other VPC is in my account, but I'm using another region. And this time I'll connect to North Virginia. And here it doesn't show up the ID by default, so I will have to go to the North Virginia region to copy the ID. Okay, so I'm attaching it with this VPC. I'm pairing it with this VPC, so I will copy this. Ignore this one, guys. This is something that I created before. So I'll copy that VPC ID and I'll put it over here. I'll create a peering connection. So now the peering request has been created. Okay, as you can see here, the acceptor is yet to accept it. So if I go here, it says pending acceptance, right? So the accepting VPC has to now accept it. So I will go to the other region, which is North Virginia, and I will go to peering connections. And as you can see here, there the peering connection request is already here, right? So I will click on that, and I will go to actions, and I will just accept the request. Once this is done, I'll accept the request. It's provisioning. Okay, so they both are paired now. It says it's active. So now can I directly go ahead and start transferring data between the VPCs, or is there something else that I have to do? Is there something that I'm missing, or is everything done? Can now both EC2s talk to each other in both the different VPCs? Security groups are always going to be a thing. So regardless of whether it is a peering connection or not, you still have to set up your security groups. That's part of life in AWS. You still have to do that, but you have to create your route table entries, right? You have to create a route where you send that traffic to the peer. Otherwise, it's not going to go anywhere, right? So here I'm on the Mumbai side. Let me just refresh this. The peering is active. For my route table, let me take this private route table as routes here. You see right now, this is only communicating with the current VPC. It's not able to talk to the other VPC. So I need to create a route, and I need to say 172.31. What was that? 172.31.0.0/16. 0.0.0/16, and that goes to the peering connection, right? So I'll select the peering connection, I'll select the peer, and I'll save. So any traffic inside this VPC that wants to go to the 172.31 will now make use of the peering connection. I need to do the same thing on the other side, which means I will go to the route tables on the other side, and this is a route table that belongs to the this is the one that belongs to that VPC. Go to the routes. I will edit the routes. So you see there is already something that says it's a black hole here. That's because whatever resource that I had previously associated with no longer exists. This is why you're seeing a black hole over here, right? I'll just remove that, and I will add a route. I will say 10.0.0.0/16 because my other VPC is 10.0. And I will say this goes to the peering connection, and I will select my peering connection. And I will save it. So now there is a route for both to talk to each other. Now I should be able to get my EC2s to talk to each other as long as the security groups are actually open. All right, any questions? All right. Guys, if you do have further questions, you know that we do have the Discord chat group, right? So please feel free to come there, discuss this in much more further detail if you'd like. We can always carry these discussions forward over there. So if you have any questions or doubts that you forgot to ask here or you need more details on, please come out to our Discord group, which should be there if you're already registered as part of the program. If not, just let us know. We'll give you the link and we can discuss over there. Okay, so that is, I believe, it for the VPC. Yep, that's it for the VPC for now. Discord group, Kasukar, just come to the Discord group. Let us know. Just ping one of us, or we are always there watching on the Discord group. So just let us know there, and we'll be happy to have a look at your assignment. But essentially, what you have to demonstrate is at least demonstrate that you're able to ping the IP from your local system to the IP on AWS, right? So if basically a screenshot itself is kind of more than enough. If you can just show that, like from command prompt or using terminal, you're able to ping the private IP on AWS, then I think that should be good. And then of course, just maybe a screenshot of the VPN setup. Okay, let me actually just quickly show you that VPN part. Okay, the client VPN endpoints, you'll find it here under VPN. Now, I already have a client VPN endpoint that's created over here. But essentially, when you do this, there is a little bit of setup involved, because when you create a VPN, a client VPN endpoint, you have to make use of some certificates. Okay, now the reason I gave you this as an assignment is because there is some documentation to follow in how to do that. So I hope you find that documentation. Just go to the AWS documentations and just search for a client VPN endpoint. You will get the link. So do that. And once you create it, there is some associations that you have to do, right? So once this is created, I can associate it with a particular VPC and a particular subnet. So if associated with this VPC, and then I will associate it with this subnet that I created, which is, I think, the public subnet. If I associate it with that, okay, I had created this VPN for another VPC. I hope this works. Yeah. So I'd basically, when you create the VPN, you're kind of creating it for a particular VPC. So that's the reason it didn't allow me to connect it to the other one. But essentially, you can see here, this is in an associating stage. This will take a few minutes to connect. So I'm not going to wait here. But once you do this, you essentially, let me just show you that. You can use this AWS client VPN software to download the configuration first. If you look at this button over here, download client configuration. Once you click that button, you can then load that configuration over here under profiles, right? And essentially what you do is you just hit connect, and it should connect. But you have to wait for this to go green. It's right now in pending associate. So once that goes green, you can connect it. You can also use your OpenVPN client to connect. Let me just bring that up. So as you can see here, I have multiple connections. Unlike your AWS client, this is a little bit more intuitive, I would say. So you have multiple connections that I can anytime turn on, turn off over here. So that's your assignment. Any questions? Okay, so I think we have approximately about 20 minutes left. I will go and try to give you a brief understanding of Route 53. So in Route 53, let's just quickly look at some of the basic concepts of domain names, and then we'll talk about DNS routing, and we'll talk about some of the common DNS record types that you have, and then we'll talk about Route 53 itself. And we'll talk about the different routing policies that you have within Route 53, some of the traffic policies, and something known as Route 53 resolver. And then I should be able to show you some labs quickly. One thing that I do want to mention as far as a VPN is concerned, guys, is once this goes green, you're actually billed per hour. Okay, so don't keep this active for too long. If you're just doing it for the labs, once you're done with doing the labs, please disassociate it. Make sure that it comes back to an yellow color state. All right, either in a disassociate, it should come back to a disassociated state, because once it's associated, you are billed per hour, and it's approximately comes to about $30 for the whole month. Okay, some of the domain name basics here. There are different levels when you talk about domain names. So there is something called top level domains. These are your .coms, your .nets, and your .orgs, right? So like the last bit of your domain names. These are known as TLDs, or top level domains. Then you have something called the naked domain, which is basically the name plus the TLD. Okay, so this is the name plus your TLD, which kind of is basically your naked domain. There is a reason it's called a naked domain, which I'll explain in a second. And then you have something called a subdomain, which is your naked domain plus something in front of it. Okay. Now, you might have so far thought, I mean, if you know this, well and good, but so far you'll be forgiven to think that these are the same. They aren't. These are actually completely two different domains. So I can have a completely different site on example.com, and I can have a completely different site on www.example.com. These are completely two different domains. Okay, because one is a subdomain and one is a naked domain. But to make things convenient, whenever someone creates a website, they actually redirect www.example.com to example.com. So even if you type example.com, or even if you type www.example.com, you're kind of redirected to one, and you're only using that one. But ideally, if you choose to, you can have a complete different website on example.com and a completely different website on www.example.com. They aren't the same thing. Just keep that in mind. Now, a subdomain can also be like mail.example.com or app.example.com. All of these are subdomains, right? Because they are sub of the main naked domain. You can also call it as a fully qualified domain name in some cases, but ideally speaking, a fully qualified domain name, or an FQDN, okay, FQDN, a fully qualified domain name, is something where you are describing that in as much detail as possible. All right. For example, server 1 refers to the server, like US-east refers to where it is. .prod refers whether it's .prod or test, and then finally you have the naked domain. So this is kind of like defining the domain as much as possible so that you can have multiple combinations of it. This is what you would call a fully qualified domain name, or an FQDN. So keep these things in mind, because we'll need it in the future slides. So before I go into how DNS works, let's just look at a basic flow of DNS. So there is something called the resolver, the root DNS, the TLD DNS, and the authoritative DNS. And the flow is always like this. The resolver will ask the root DNS. The root DNS will pass that information to the TLD DNS, and the TLD DNS will pass that information to the authority DNS, which will then finally pass the information back to the resolver. Okay, this is the flow, but I'll show you how this flow happens. Okay. Yeah, Harish has a question. Could you please show a small demo for naked domain and subdomain? So far I have used both, seems same. That is exactly the point. I will show it to you today, hopefully within the next 15 minutes if we have the time, but I should be able to show it to you, no problems. Okay, the resolver is the one that actually does the resolving. So what is DNS per se? DNS is domain name system, where basically you have a name being resolved to an IP. Okay, the reason is simple. As humans, we are not good at remembering numbers, because IP address, I mean, of course there are geniuses who can remember big numbers, but not all of us are geniuses. So we have issues remembering numbers, and some of us are not good at maths, so we're not good at remembering numbers. Okay, but we are good, kind of better at least, in remembering names. So it's easier for us to remember like google.com instead of remembering the IP address of google.com, right? I think there was a time when we used to all remember our phone numbers of our family and everyone, but today we have it as contacts in our phone books. So, yeah, same thing. So, DNS allows you to convert a name to an IP address because as humans, we are good at remembering names, but computers still use the concept of IP addresses. They need to know they need to know the IP address in order to fetch something. Okay. So, DNS allows that translation to happen between name to IP. So a resolver is the one that actually starts that process. So the resolver goes and finds out what is the IP. That's the job of the resolver. Okay. Um, the root DNS is a set of servers. I believe it's a set of 13 clustered servers, which has information about all of the TLD servers. Okay. So the TLD servers are what? The .coms, the .nets, etc. So these are managed by certain organizations. For example, .com, I believe, is managed by VeriSign. VeriSign. I think, yep, I think it's managed by VeriSign, where they take care of the complete .com TLDs, right? So the root DNS has information about the servers about .com, the servers about .net, etc. Right? It doesn't have all of the information about the domain names itself, but it has information about the servers that are handling the TLDs. Okay, and the TLDs have the information about the servers that are handling the naked domains. For example, example.com. Okay, this is a naked domain. So the TLD DNSs for those particular TLDs has information about the servers that are handling each and every naked domain belonging to that TLD. Let me show you the diagram. It will become a little bit more clear. So as an example over here, we have a user who's trying to go to www.example.com. So there is the web server which he needs to access. The web server's IP address is 102.15.2.91, and this is the web address. Okay, so in order to fetch this page, www.example.com, the user needs, oops, what happened there? Yeah, so in order for the user to load the web page on the computer, this computer needs to go ahead and find out this IP address. Once it finds out the IP address, it will make a direct connection and then load the web page. That's the whole idea, right? So over here, you have the web server, and then you have something called the authoritative DNS or name server. This name server or the authoritative DNS is the one that holds the information about the naked domain. So the naked domain here is example.com. It holds the information about all of the subdomains of the naked domain. So for example, here www.example.com, mail.example.com, db.example.com. This authoritative DNS knows the IP address of each of this. Okay, it knows the IP address of each of this, because it's in the same network, or it's kind of associated. So the authority DNS knows the IP address of www.example.com is this. That information is with the authority DNS. So ideally speaking, this computer needs to ask the authority DNS the IP address for this in order to get this IP and then make a direct connection. But it is not that simple, because there are other servers that are involved in the process, which is the root DNS, the TLD DNS, and the resolving DNS. Your resolving DNS is normally your internet service provider when you have your connection set up for the first time. Your internet service provider will kind of configure the resolving DNS on your connection, on your router, and whenever your system wants to find out something, it will go ask the resolving DNS, and then it will start from there. Let's see a flow, how this happens. So the user wants to find out the IP address of www.example.com. Let's assume that this is the first time they're doing it, because if they've already done it, normally the IP is stored in the cache of the system. But let's just assume that this is the first time that they're doing it. So the first step is the system will ask the resolving DNS, can you find out the IP of www.example.com for me? The resolving DNS will then first ask the root DNS, hey root DNS, can you tell me the IP address of www.example.com? Remember, the root DNS does not have information about that subdomain or that naked domain, but it does have information about the TLD servers that is handling .com. So what it will do is it will tell the resolving DNS, I don't know the exact IP address of www.example.com, but I know the IP address of the .com servers. So here is the IP address. Go ahead and ask the .com server. Okay. So the resolving DNS will get the IP address of the .com TLD. It will then ask the .com TLD, hey, can you give me the IP address of www.example.com? Here again, the TLD does not have the information about the subdomain, but it has information about the naked domain, as in it knows the server that is handling the naked domain. So it will reply back saying, I don't know the exact IP address of www.example.com, but I know the server that is handling example.com. Here is the IP. Go ahead and ask it. Okay, so that IP will be returned, which is basically the IP of the name server or the authority DNS. And finally, the resolving DNS will ask the same question. Hey, can you give me the IP address of www.example.com? And obviously, this time the authority DNS does have that IP because it has the information about that subdomain, and it will return back that IP, which is 192.15.2.9. And it will return then that IP to the system, which then, once the system gets the IP, it will then establish the connection to the server. All of this process, whenever you type a website address, happens just like that. At the split second, all of this is actually happening in the background when you search for a domain name. Okay, so keep this in mind. If DNS system does not exist, your internet is not going to work. Okay, so this is a very core function of DNS for the internet to survive. And you're not always directly connecting. There's all these queries that are happening. However, in order to save this process from happening again and again and again every single time, once you get the IP address, you tend to store that IP in the cache of the local system. Okay, so that every time it does not have to ask this question that you need to ask you need the IP, because the next time you need to access this, it will go ahead and just directly connect to the IP. Okay, can someone tell me which part of this do you think is Route 53? Where is Route 53 here? Which is the system Route 53 here? Is it the resolving DNS? Is it the root DNS? Is it the TLD? Is it the authority DNS? Which part is Route 53 here? Do you think? Nobody? Anybody? Which part do you think is the Route 53 over here? Ten more seconds. This is your Route 53. Okay. Basically, you are going to add your domain to Route 53, and this is your EC2 instance. Okay. So you're going to add your domain in Route 53, and all of the records will be created inside Route 53. So all of the records for www.example.com, mail.example.com, db.example.com, etc. will be created inside your Route 53, which will act as the authoritative DNS for your domain. What that basically means is once you add your domain to Route 53, if anybody wants to find out the IP address of your domain, the end request will have to come to Route 53, and Route 53 will answer, giving back the IP address. So that's the job of Route 53. Route 53's job is to answer queries on your behalf for your domain name, and then it will always return the IP address of wherever you have hosted that domain. Okay. Now, remember I told you about the cache over here. It is also important to specify that cache when you create the record. So for example, if you create a record for www.example.com inside Route 53, you have to specify that cache, and this is where that cache concept of TTL or time to live comes in. Okay, so if you specify a TTL of 30 minutes, that basically means this IP address will remain in the user's cache only for 30 minutes. after 30 minutes that cache will expire. So if the user needs to again go to that website after 30 minutes, he needs to again go through this whole process again in order to get that IP. Okay. If you say a TTL of 1 minute, then obviously the cache will expire after 1 minute. You have to decide between how long you want to keep your TTL and how short you want to keep your TTL. Because if you keep your TTL too short, let's say you kept your TTL only 1 minute, okay, this means anybody accessing your domain will have to again and again after every minute they'll have to come ask the question to Route 53, and Route 53 charges you based on how many queries it's answering. Okay, so if it answers 100 queries, you pay less. If it answers 10,000 queries, you pay more. So if you keep it too low, then you're answering more queries from Route 53. However, you don't want to keep it too long as well. For example, if you keep, let's say, a TTL of 1 day, okay, uh, everybody will have this IP stored on their system for 1 day. But what if something happens to your server and you had to change the IP, and now www.example.com goes to 92 instead of 91? What happens then? When people try to access it, they will try to go to 91 because their TTL is still 1 day and the website won't load. All right. So you have to kind of balance this between, how quickly you want to refresh the cache versus how long you want to let the cache be there. So that's up to you. A couple of important things to just keep in mind. A record is basically IP of a domain name. Okay, so if you have like example.com, the A record for that will basically be pointing to an IP address like 52.16.9.3 or something like that. Okay, it'll just be pointing to an IP. NS record is basically the IP address of the name servers. So every domain will have an associated DNS or a name server. So every domain name will have a name server IP that is associated with it. This is so that they can find out which name server to get to. The CNAME or alias record. So this is where one domain name points to another domain name. This is the example where I wanted to tell you about the www.example.com pointing to example.com. So this is where you normally create a CNAME record and you say that anybody typing in example.com, it's a CNAME of example.com, which means it's basically one domain redirecting to another domain. That's essentially what a CNAME is. I mean, there is more to it, but that's essentially what a CNAME is. Then you have MX records if you have mail servers. Then you have something called SOA records or start of authority. This will always be there by default. This is basically establishing like who's the authority for your particular DNS. Then you have something called TXT records. You use this if you want to do additional validation. For example, if you want to verify that you are the owner of the domain, you will get some TXT records that you have to create within your DNS so that they can confirm that you are the owner of that particular domain. All right. Route 53 itself is going to act as the authoritative DNS for your domain name. So it will answer queries on behalf of your domain name. So you will you will add your domain name in Route 53 and you will add the records for Route 53 inside that. There are different types of routing that are available. There is something called latency-based routing or LBR. There is geolocation-based routing. It also integrates with other AWS services. And of course, if you want, you can register a domain name. Okay, so I think we are almost coming up to 2.5 hours. Sanchit, do we want to like maybe wrap up this Route 53 itself? Maybe another 15 minutes, maybe, or do we want to come back? And let me also put that question to the audience, guys. Do you want to like continue with this right now, finish the Route 53, or maybe we'll come back next weekend and wrap this up? Probably another 20 minutes. Question to the audience, let me know. Okay, so I think, yeah, I got about 4 or 5 continues. So I think we will, we'll go ahead and we'll finish this up. Thank you, guys. Okay. So let's talk about the different routing policies. Let's start with a simple routing policy. So in Route 53, a simple routing policy is essentially you are creating something called an A record. You are having a domain name that you're routing to an IP address. In our example over here, I have a load balancer which has some EC2 instances behind it. Now, normally you would actually have a domain name that is associated with your load balancer, but let's take an example over here and let's just assume that this load balancer has an IP address. Okay. So we want to send anybody looking for www.example.com, we want to send them to this IP address. That's our goal. So what we will do is in Route 53, we'll create this record in Route 53. And when someone queries for the domain name, it will pass through all of those steps that I just showed you in the previous screen. And then it will finally hit Route 53 and it'll ask for the IP address of www.example.com. And Route 53 will say, here is the IP address, go ahead and connect to this. And then the user will make the connection to that IP address. Remember, Route 53 does not route the traffic. Keep that in mind. Okay, it does not route the traffic through Route 53. It only responds and gives the IP back to the user. The user then has to make a connection separately to that IP address. Okay, just keep that in mind. So it's not a routing traffic like ELB or anything like that. So that's a simple routing policy. Then you have something called latency based routing policy. This is if you have multiple environments and then you have to you can basically route users based on their latency between their location and the nearest region. So for example, over here there are 3 regions that I'm using: North Virginia, Oregon, and North California, and I have the same content in all of the regions, right? I don't want to have different content because I don't want to have different users going to different content. I want to have the same content across all of them. So I have a website running the same content across all of the 3 regions. I will set up latency based routing. And what happens is Route 53, because it's a highly available and highly scaled system, it knows the latency between the user's location and all of the different regions. So it knows the user's latency between North Virginia and the user is 20 milliseconds. The latency between Oregon and the user is 35 milliseconds. And the latency between North California and the user is 42 milliseconds. So what do you think is going to happen here? Which IP do you think Route 53 will return? Route 53 will return the lowest latency routing in this case, which means it will return the North Virginia IP. So it will return back to the user go to IP 10.65.2.6. Now, this might not always be the same. The next time if the user queries, if this is, for example, 18 milliseconds or something like that, then the next time he will get this IP instead of the other one, right? So this is what it is. You can always get the user to connect to the quickest region that is next to him. Okay, this is assuming that you have something set up there. Okay, it's not just going to directly just give that. You have to have something set up. Then you have weighted routing policy. This works in a similar fashion, but this does not look at where the user is. Rather, this looks at trying to balance your environment in some way. Okay, so let's assume that you have set up a weightage of 25% goes to North Virginia, 15% goes to Oregon, and 16% goes to California. Remember here, this is not traffic percentage. You're not doing load balancing. Okay, you are just saying that if somebody queries, the number of queries that is coming in, you respond back in this percentage. Okay, I'm telling Route 53 to do that. So when people query, for example, www.example.com, 25% of the time they will get this IP, 15% of the times they will get this IP, 60% of the times they will get this IP. Now, even if I made this 33, 33, and 33, it's still not load balanced. Maybe the first time it's load balanced, but then after that it is not balanced because, okay, stay with me for one quick minute here. I'm going to try to explain this to you. If 100 users come in at 10 a.m. and requested for the site IP, 33 of them will get this one, 33 of them will get this one, and let's say 34 here. Okay, 34 of them will get this one. Okay. Maybe at 11 a.m., out of this 100, 50 people returned. Okay. At 11 a.m., 50 people returned. Now, do I know which 50 people those are? It might be 33 from here and 20 from here. right? I don't know. Like, you can't control that. Once the user gets the IP, you can't control how many people come back to that same environment. So this is not load balancing. Okay, but when you're, I mean, it does it on some level, but this, you don't do the load balancing over here. You use something else, which we will discuss in our next session, how you actually do global load balancing um, using other services. But you do this again if you only have the same content. You don't want to do this if you have different content. And then you have something called geolocation routing policy. The way I would describe this is, think of it like YouTube, where if you go to youtube.com, depending on which country you're opening it from, you will see different content, right? So if you're opening it from the US, you will kind of see US related content. If you're opening it from India, you will see India related content. This is because you are being redirected to an environment that you are supposed to go to. Okay, this is where I'm hard coding, saying that if anybody is coming from US, always return them the IP address of North Virginia. Okay, if anybody is coming from the European Union region, always return them the IP address of London. If anybody is coming from the Asia region, always return the IP address of Mumbai. So this way I'm controlling from which region people are coming and which region I need to redirect them to. This way I can have different content in each of these environments that are specifically suited for that particular country or for that particular region, so that they see only that content. This is essentially what geolocation routing is, and I'll definitely show you this in action. And then the final one is failover routing policy. Failover routing policy is where you have something called an active, which is primary, and then you have a standby, which is secondary. Okay, your Route 53 will always return the primary, always return the IP address of primary. So whenever someone queries for it, it will always return the IP address of primary, unless and of course something happens to the primary. Then it will stop returning the IP address of primary and it will start returning the IP address of your secondary. So it's up to you whether you want to completely keep an environment running in secondary always, or maybe you just want to have like a static web page on S3 which says that we are currently experiencing some difficulty, please come back later, or something like that, right? It's completely up to you. But the idea here is that you will have a primary and you will have a secondary, and there will be a health check that you're running. And if primary fails for some reason, then it will start giving the IP address of the secondary. Till that time, it will always give only primary. Harish has a question. Does GPS takes place part in geolocation routing policy? So not really GPS. What happens is there is globally a list of IPs that belong to certain regions, right? So for example, when you're logging in from India, regardless of your GPS location, you are connecting with some data provider, right? If you're using a SIM, you're obviously using a cellular data provider. If you're at home, you're using some broadband provider. All of these providers have a block of IP addresses, and those IP addresses belong to a certain region, right? So based on that IP location, they will kind of decide where you're coming from. So if you're coming from a IP block that belongs to, like, say, India, then you will be identified as someone coming from India, which is why when you go to certain websites, it tells you that this content is not available in your region. That's basically that. They look at your IP and then decide which region you're coming from. Okay, now we talked about all of these different routing policies, right? Simple routing policy, latency based routing policy, weighted routing policy, geolocation policy, failover policy. You actually have the choice of either using these policies individually, or you can also kind of chain them, okay, using something called traffic policy. So over here, as an example, I can start off with a failover routing policy. I can have a primary and a failover. Okay, so in that failover routing policy, under primary, I can have weighted. So within primary itself, I can have a weighted routing policy where they go to two separate endpoints, so that the traffic is kind of balanced, I would say. But if for some reason this entire primary fails, then I can switch over to the failover and it can go to endpoint. So I can in fact kind of chain multiple policies together in order to create something called a traffic policy. Okay, any questions on this before I go and show you the labs? Okay, Let me show to the labs. Okay, before I show you the labs itself, let me kind of just show you that DNS flow. There is a website where you can actually see this. Okay, I'll look that up later and I'll show you that flow. But I can show you that flow as to how it kind of flows through. Okay, just to show you that VPN part, you can see it's available now. So if I want, I can actually just go ahead and connect to it. I think this is in Mumbai primary. So I'll just quickly connect to it. Okay, I think my profile is not the right one. Okay, actually I had the VPN service is disabled on my system. Okay, just make sure that if this is actually showing available and you're done with the labs or whatever, make sure you disassociate the associations for your VPN. Otherwise, you'll be charged. So just keep that in mind. Okay, Route 53. So in Route 53, there is something called hosted zones. This is where basically you add your domain into Route 53. There is a question about the cost. So in Route 53, you can choose to either register your domain in Route 53, which will cost you depending on the extension. For example, I think a .com domain costs you around $13 or something like that, right? But it's not necessary for you to register your domain with Route 53 in order to use Route 53. You can register your domain someplace else like GoDaddy, or in fact you can use our service, which is outpowerhosting.com, and you can register your domain there. But once you register your domain, you need to still add that domain into Route 53. You do that under hosted zones. So regardless of whether you bought the domain from Route 53 or not, you still have to add your domain under hosted zones. So you just create a hosted zone, type in your domain name over here, and it will mostly be public. Private is if you want to use DNS only within your VPC. Okay, but this time we are just using public. So type in your naked domain here, and you can just create a hosted zone. When you do that, you will see your domain over here. For example, I have this domain here, aws-training.in, which is a naked domain that I've created over here. Excuse me 1 second, guys. Sorry about that. Okay, so I've added this naked domain into Route 53, and as you can see, I already have some records in Route 53. Normally, when you create or add the domain into Route 53, you will see two records that are created, and those are these two records: the NS record and the SOA record. Remember, I told you SOA is like start of authority. This will always be there by default. Don't delete this. And NS is basically the name servers. So it's basically Route 53 is telling the whole world that if you have any questions about aws-training.in, the name servers that are responsible for answering that question are these four name servers. Okay, so all of the queries about aws-training.in will hit these four name servers, and these four name servers will make use of all of these records that I've entered here in order to answer the question. Okay, so once you add your domain name into Route 53, you need to make sure that your domain's name server matches these four records. And once you do that, you can then go ahead and start creating records. So let's do that. Let's first start off, and let me quickly create. Yep. Let me quickly launch maybe 1 or 2 instances, and I'll just show you. I'm just going to put a couple of simple websites on. Just give me one quick second. So I'm creating an EC2 instance which has a website on it, and in fact, I'm just creating quickly a couple of instances which I can show you how the routing works. Just give me 2 minutes. Okay, so I have about 3 websites and we should be good. Let me. Okay, as an example, I have an EC2. Okay, I have an EC2 with a public IP address inside which I have basically installed this website. Okay, this website is called Editorial. And right now, as you can see, I'm opening up this website with IP address, right? But I don't want to use IP address. I want to use a name because I can't give this IP address to everyone else. It's hard for them to remember it. So I need to use DNS. So what I'll do is I'll take this IP address, which I will need, and I'll go to Route 53 and I will say create record. Okay. Now, like I said, you have multiple routing policies, simple routing policy, weighted, geolocation, etc. So let me first create a simple routing policy and show you how this works. So I'll select simple routing policy. I will keep a load detail of 1 minute because I'm just doing it now for temporary use. And let's say I am creating this site called site.awstraining.in, and I will put in this IP address over here as a value, and it's an A record. And A record basically means name to IP. Okay, so the website is basically site.aws-training.in, and the value, the IP address is this. It's a simple routing policy, and detail is 60 seconds, and I'm creating the record. So as you can see here, this is the record that's got created, simple record for site.aws-training.in that goes to that IP address. Now, if I take this name and if I put this here and hit enter, as you can see, it works. In fact, you can try going to this website right now and see if it works. Go to site.aws-training.in. Site.aws-training.in. You can go to the site and you can see it works. So essentially, I got a website up and running in under 5 minutes with the use of EC2 instances with some quick code in it, along with DNS. So it barely took me 5 minutes to put up a website. Does it work for anyone? I do want to mention that if you do add your domain into Route 53, there is a cost of 50 cents per domain name per month. So that's $0.50 per domain name per month. Okay, so just keep that in mind. It's not much of a charge, but it's still a charge. So keep that in mind. Did the website open up for anyone else? Okay, so that is a simple routing policy. So I have one server handling one IP. Okay, that is one routing policy. So let me just go ahead and create the other routing policies that I mentioned. So for example, I will create a weighted routing policy, and you guys need to actually play along with this because I will create something called W1, and I will actually use this website, which is the other two servers. One is called 40 and one is called Massively. So I have two other websites that I want to show you. One is called Massively and one is called 40. So I'll use these IP addresses to create. So I'll again, I will basically create a weighted routing policy. And I will say this. And because this is 0 to 255, I will say a weighted routing policy of 126 or 127. And then I will add another record and I will do the same thing, W1. So it's the same record that I'm creating, w1.aws7training.in and w1.aws7training.in. But I'm sending this to two different IP addresses. Let me just show you that. As you can see here, the two values are different, right? The two values are different. And I'm using weighted routing policy for both of them. And the values are split 127 each. Okay, but both of them are going to w1.aws7training.in. And if I make this to 1 minute, make this also to 1 minute, create the records. Okay, I just need to give it a name. So I think this belongs to Massively. So I'm just going to call this Massively and I'm going to call this 40. So just a name for identification. Create records. As you can see, I have created a weighted routing policy for the same domain, w1.aws7training.in. So I want you to go to this site quickly and tell me what site are you getting. So if I go to w1.aws7training.in, I'm getting 40. Please tell me what sites are you getting. Whoever is trying it, quickly, please. Anybody getting the Massively website? Because ideally it's supposed to be 50-50, but like I said, it's not exactly a load balancer. You're not going to get exactly the correct split, but okay, so someone else got Massively. Anybody else who tried it? Dora Chowdhury got Massively. Harish and Mohammed, are you still on? If you can just quickly tell me what you got. Mohammed also got Massively. But as you can see, I got 40. Now, if I refresh this, I get Massively because my TTL was 60 seconds, right? So the cache got cleared and now I'm getting Massively, right? After 1 minute, if I try this, I will again get something else. So that's basically the weighted routing policy. Similarly, you can create your geolocation routing policy, latency routing policy. I mean, I can't really demonstrate this to you right now because we are all in the same region. If there were people from different regions, we could actually test this out. Especially with latency, it's just a matter of depending on where you are, it'll give you a site. So I can't really say what site you're going to get. But just to show you what it would look like if you were to configure geolocation. So if I were to configure geolocation, I will get the option which says which location do you want to send. So I have multiple options here. I can say continent wise, so Africa, Antarctica, Asia, Europe, North America, Oceania, and South America. So I can send entire continents to a particular IP address, or I can send it country wise, right? So if I say, for example, India, if I say everyone from India should only go to, if I say everyone from India should only go to massively site, then they will only get massively site. They will not get any of the other ones, regardless of how many times you refresh, regardless of how many times your cache expires, because I am hard coding here saying that anyone coming from India will be routed to this IP address. Similarly, I can do it for other countries as well. The only thing that you need to remember additionally over here is that if you do select United States, in US, you actually get to send them state-wise. So if you are selecting US, you can actually redirect people based on states within US. So you can send people from certain states to certain environments, and certain other people from certain states to different environments. So you could do that if you wish to. Okay. How is this going to be different when you have not IP addresses, but for example, if you had a load balancer, right? If you had a load balancer, instead of selecting an IP address over here, you would actually select alias. So you would turn on alias, and you would choose an endpoint, and you would say something like your application load balancer, right? And then you would choose your region where your application load balancer is, for example, Mumbai. And then if your load balancer is there created, it will show up on the list. But right now I don't have a load balancer created. That's why it's obviously not showing up in the list. But it's the same idea. Instead of an IP address, you're going to use the load balancer. So whatever instances are behind your load balancer, that will load up. Now, the last thing I want to show you here is running a website off of S3. So if you go to your S3 buckets, you can actually have websites running off of S3 as long as your bucket name matches the domain name. For example, you see over here, I have a bucket name www.aws-training.in. Okay. If you go in there, it's basically some static web files. So I have that bucket name there. And if I go into create a record, I can say, for example, www. It has to match the bucket name. Okay, this is important if you're doing if you're sending websites to S3. So www.aws-training.in, and here obviously I will select alias because it's an S3 bucket. So I'll select alias, and I will select S3 website endpoint, and I will select. Okay, where is that bucket? This bucket is in Mumbai. I'll select Mumbai. And okay, the reason it's not showing up here is because I have already created this record. But essentially, it will just show up that bucket name over here, and you just need to select that bucket name. Let me show you that record that's already created. Here is that record. Okay, I've sent this to Cloudfront. Let me see, I've created somewhere else. Let me see, www. Why is it not retrieving? Cannot retrieve. Okay, I think that is because. Oh yeah, I've already created the www record, right? So obviously it's not going to like allow me to create another one because it's a simple record. If I had created it under weighted, or if I had created it under geolocation or something like that, then I can create multiple records of the same name. But because it's a simple record, it's not going to let me do that. But let me see. I think I have another bucket I can show you. Yeah, so there is this site.aws-training.in. Yeah, I think I can show you that. Let me actually edit this record. So I'm editing this site.aws-training.in. I will select alias. I will select S3 web endpoint. That bucket is in North Virginia. No, that bucket is in Mumbai. Okay, and I will select Mumbai. Okay, there you go. So I have a bucket called site.aws-training.in. So I selected endpoint, I selected bucket name, simple routing policy, and save. Now, because I actually overwrote a record, remember this was already created. This was the first one I just created when we started our labs. So obviously this is already cached in memory. So it might not directly open up the bucket, but let's see. So it's still opening the cached information, right? So remember, this is why TTL matters. If you're constantly changing your environment, if you keep your TTL too high, then obviously people are going to get the old one, right? So let me see. I think, yeah, there you go. So the TTL was just a 1 minute TTL, right? So there you go. This is actually the site loading from S3, right? So this site is basically a static website loading from the S3 bucket. Now, I think I need to go back and answer that question of, can you show the website running with www and aws-training.in, right? So let me show you that. www.aws-training.in. This actually goes to another AWS bucket through a Cloudfront distribution. Okay. So here is a site, www.aws-training.in. And okay, I've actually set up a redirect. Hold on. So aws-training.in. Yeah. Let me do one thing. Let me edit this. Edit record. So you see here, I had actually already selected redirect. So that gets redirected to this, right? This is the reason that it's actually going back to the www site, right? But if I want, I can just host a static website over here, and I can say index.html. I can save this. And I go back to the bucket. I can upload. Give me a second. Why is all of them failed? Okay, so this is www.aws-training.in, and then if I just take My browser might still redirect because it probably still has cache, but let's see. Okay, there you go. So I hope this answers your question that I can have completely different websites. Let me just refresh this to confirm. So you can see I can have completely different websites on www.aws-training.in and aws-training.in, right? So this is what I meant by saying that they are completely different domains. Of course, for convenience, I can have it redirected some back to the same domain in order to avoid confusion, because I don't want people to go to two different websites when they type the two different domains. I just want to make sure they're in the same one, right? So any questions? All right, I think we have taken up too much time today, so I'm going to stop here for the day. And hopefully, once we come back next week in our next session, we can actually go ahead and do the remainder, which is Cloudfront as well as Global Accelerator. If anybody has any questions, please do post it in the chat. And for those of you who are watching this after the live session, if you're watching the recording, please do post any questions that you have within the comment section, and we'll definitely try to answer it. And if you're unable to do that, you can always come to our Discord session and post it there. So with that, I'd like to thank everyone for listening in, and let me hand it back over to Sanchit.
Thanks, Faisal. That was very elaborative session with backbell demo. Thank you so much for taking out your time today. Yeah, I think as Faisal mentioned, I'll try to remind everyone, if you haven't registered so far with us, please do the same. The link is given in the description of the video, and all the guys who will register before end of day will start getting will get an email around the Discord link, so you can join our chat group. And any questions, queries, materials you need, you can reach out to us on via Discord forum. So we'll be happy to help you out with that. With that, we wrap up our this week's session. We will be back with the, as Faisal mentioned, the remaining of the sessions and the content for next week. Thank you so much for joining both the sessions for this week. Stay safe. We'll see you in the next week. Thank you.